And we are starting. Dear colleagues, we are really happy to have all of you at the 6th International Conference on European Dimensions of Sustainable Development. And we are happy to have welcome words, welcome speech from our Vice Rector on behalf of the Rector of our university and on behalf of all our community, Dr. Sergey Volodymyrovich Tokarczuk. And please, Sergey Volodymyrovich.
Дякую, Юрій Леонідович. За ваш дозвол все ж таки я буду українською. Шановні друзі, щиро вітаю вас у віртуальних стінах Національного університету харчових технологій, одного з провідних технологічних закладів або університетів України. Сьогодні ми з вами зібралися на щорічну, вже 6-ту за порядком, конференцію з європейських вимірів сталого розвитку. Конференція наша була започаткована за підтримки проєктів програми Erasmus+, і за ці роки стала доволі активною дієвою платформою для зустрічі усіх науковців, які зацікавлені у сталому розвитку Європи. І як ми бачимо, з кожним роком наших друзів, партнерів, які приймають участь у цій конференції, стає все більше і більше.
I will translate briefly. The main idea that Dr. Tokarczuk welcome all of us, and it's the 6th international conference, and it's really the platform for sharing this idea of European sustainability. And again, it started under the support of Erasmus Plus program, and we are happy that we are continuing. Yeah.
Наші сьогоднішні секції, які будуть діяти, охоплюють майже усі складові сталого розвитку Європи. Як ви самі бачите, це і економіка, це і соціальні виклики, це і екологія, звичайно, це і передові технології. Серед учасників присутні науковці, дослідники, фахівці самих різних галузей знань. І тому, я думаю, що комунікація, співпраця між нами дасть потужну енергію для розвитку і України, і всієї Європи в цілому.
Okay, and as you see from the program, all sections or pillars of sustainable development are here: economy, environment, science, social issues. And again, we are from different fields of science, and that is why we hope to have this real synergy of our collaboration. Yeah.
Сьогодні Україна переживає надзвичайно важкі часи російської агресії. Ну і ви всі це бачите, що практично щоденно ворог атакує наші міста і села, і саме зараз підтримка наших друзів-партнерів для нас надзвичайно важлива. Символічно, що на нашій сьогоднішній конференції зібралися представники, науковці фактично з усього світу, і всіх нас об'єднує бажання жити і працювати у вільному і справедливому світі, без воєн, терористичних атак, де науковці можуть працювати на покращення життя суспільства, захисту довкілля, забезпечення соціальної злагоди.
Now, Ukraine is going through the really tough time, and that is why the support of our international friends, our international partners is really important for us. And we believe that victory will be with us, and we believe that we scientists will work in our fields to, let's say, for better future of Europe, for better future of all of us, and forget about this really tough time.
І ми віримо, я думаю, без виключення, що добро в будь-якому випадку переможе зло, і настане той час, коли ми з вами зможемо зібратися в реальних стінах нашого університету, за багато кращих обставин, і ми завжди будемо вдячні кожному з тих, хто був поряд з нами в цих важких умовах. А всім своїм українським колегам хочу побажати, звичайно, витримки, віри в перемогу і наснаги робити свій внесок на наближення перемоги, кожен на своєму місці. Впевнений, що наша співпраця, яка буде започаткована або продовжуватиметься під час даної конференції, буде робити свій внесок у розвиток України, Європи. Бажаю всім нам сьогодні впродовж 3 днів конференції плідної роботи. Ну і, звичайно, не можна сказати дякую Збройним силам України. Завдяки їм ми сьогодні можемо зустрічатися, працювати. І саме вони боронять сьогодні майбутнє не лише нашої країни, України, а й всієї Європи. Дякую всім, хто приєднався. Слава Україні!
Дякую, дякую, пане Сергію. So briefly, we believe that hopefully soon we will meet again in real walls of our university in much better conditions. We believe in our victory. We believe that actually the situation will change, and we always will remember support of our friends, our partners in this tough time. It's really important for us today, and for us Ukrainian scientists, it's important to do our work, to do our job, and again to help our victory in our own places. And we really thank to our armed forces of Ukraine. They are now defend not only Ukraine, they actually defend all the Europe. Glory to Ukraine, glory to heroes. Дякуємо, дякуємо. Thank you, Dr. Tatarchuk. And colleagues, my pleasure to welcome head of our National Erasmus Office, Dr. Svetlana Shitikova.
Good morning, dear colleagues, dear friends. And as you know, today is also a family day. And let me wish you all families, and on behalf of Erasmus Plus family, which has already a long-term history, to wish you all be healthy, be safe, and also do not stop and never stop in your development. And such conference, in fact, shows that it has been a very important and critical topic, which was launched 3 years ago, and it has been continuing despite of everything. And I would like to thank to all our resilient Ukrainian Erasmus family, and to each of you as teachers, as staff of the universities, as the head of universities, that you actually contributed a lot in cooperation with our international colleagues, starting 30 years ago from Tempus time, in fact, to the new generation, the generation of defenders, the generation of titans, who are now defending not only Ukraine, but all Europe. And of course, the program has been always in the development, and it has been always developed and devoted to the key topics of the sustainable development and of the key strategies of European Union working with different countries throughout the world. And Erasmus Plus is one of the instruments of internationalization and also of the implementation of the key strategies in education, youth, and sport, not only in Ukraine, but also in the whole world. And I was going to show you a few slides to highlight the importance of the instrument and the policy it covers. If I may share the screen, I will do it.
Yes,
otherwise,
yes. Yeah, please.
Good. Yeah, just I hope this presentation will start. Okay, do you see the strategies, European Union and world?
Yes.
Great. So these are the key strategies which in fact are covered by Erasmus Plus program. And I'm sure that within each of its pillar, you can find the important topic for your university, for you as a professional, for further development and in cooperation with the international partners. Erasmus Plus started in 2014. Tempus started in 1994. And also Erasmus Mundus started in 2004. So therefore, we have a long-term history of cooperation with many partners. And all of you have seen, in fact, the developments and the changes within your university, like each university in particular, as well as the professional development. And in fact, if you have a look into the strategies of EU and the world, where you could see the key pillars of sustainable development goals, the digitalization, the green transformation, the in fact the inclusiveness, and also democratical values, you could also highlight and have a look into the strategies of Ukraine within these pillars. And in fact, working together on the home task, being a candidate country to join the EU and in the negotiation stage, each of us also contributes to the enlargement policy, where we are all the time reports about the developments. And Erasmus is an instrument to implement reforms in the spheres of the program, like education, youth, and sport. As you know, that within Erasmus Plus, we have the key focus on the development of the universities. And in terms of the strategy of the universities of the European Union, the European strategy for the university comprises the pillars for the university alliances, European university alliances in particular. And among all these 4 key priorities, the key one is based on the quality of education. It's also on the identity of European education. And Ukraine, as the candidate country in the negotiation stage, is also going to be among the EU member states. And as you can see, that working in the European University Alliances, we are going to learn also what are the challenges within EU and where we could contribute together, what can we change, that being already a EU member state and being a part of a large European universities alliances, we will be ready later on to become the full partners, not only in the Erasmus program, but also the equal partners on the educational market. So I would like to wish you today to discuss the key topics, to share the experience you learned, to learn new maybe ideas for the future projects, and to apply for the new call. It is going to be started in November this year, and among all of things, we have 39 calls for proposals open for Ukraine in cooperation with the EU member states and other countries in the world. The opportunities are there. What to do, each of us know, based on the needs of especially of each university, and based on the needs of our Ukrainian higher education, to become more competitive and to be an equal partner with the whole world. Let me also send the warm wishes from all our Erasmus Plus team, and also from the our partners, EU delegation to Ukraine, European Executive Agency for Education and for culture, for education and culture, from the Ministry of Education and Science of Ukraine, who are working together with you, trying to negotiate more opportunities to be open. But in any case, we are all working together for our victory and to then build new Ukraine as an EU member states and equal partner. Please stay safe and have a nice event, very useful, very practical for these 3 days, three days. And I'm sure that it will also bring more value for our contribution to further development to the victory. Thanks a lot to all of you, and hope that we will have the opportunity to welcome our international partners and to implement normal Erasmus in the future, but also continue working now. Thanks a lot for all your resilience. Slava Ukraini.
Героям слава. Thank you, Dr. Svetlana Shetikova, for the great, I would say, the great introduction into our conference, and for your permanent support, you and all of your guys, your team, and it's really, really supportive. Thank you very much. Thank you. So, people, we are going to our actually first plenary session. Again, I will be the moderator of this session, And just before the first report, actually it will be my colleagues and my report, the brief, let's say, technical ideas. First of all, we are following the program. Speakers will have about 20 minutes for report and a few minutes for question answer section. Again, listeners, please ask questions, but not discuss after the each report. I mean, we will have special section of discussion, general discussion at the end of each section. That is why it's like only question and answers after each speech. And I guess if you will have some, again, technical question or any other question, you may use chat or you may actually ask orally after the presentation. And please, during the presentations, keep your mics mute, and we are starting. Any technical questions? No. Okay. Then, if you don't mind, I actually will start the very first report, the very first presentation of our plenary session. It actually will be my colleagues and mine. I will try to share screen just now, and we will go. Okay, just now you should see the full screen presentation. It's okay, and I change the slides. Okay, the general idea of European sustainability is actually close to the idea of sustainable development as it was formed by the United Nations, famous the Common Future report back in 1987, and the idea very bright, very generous. We should keep, let's say, normal management of our planet to meet needs of our generation and to provide this opportunity for future generations to meet their needs. Yeah. And other important issue, again, classical idea of sustainable development, we at least need always keep in mind three main pillars, three main components of sustainable development: economic growth, environmental protection, and social inclusion. Yeah? These three pillars interconnected, intersupportive, something like that. And just for today's situation, yeah, on the planet we have more than 8 billion people, and we all want to eat every day. So annually we produce about, we humanity produce about 70 billion animal farms, animals, I mean mostly chickens, but other stuff like pigs and cows. So it's a huge pressure on our planet. Yeah. Look here. If we compare these numbers with numbers of wild animals, only maybe 100,000 of monkeys or just a few dozen thousands of lions or bears. Just now, it's really terrible assessment. About 97% of all terrestrial vertebrates, it's us humans and farm animals, and only 3% are wild animals. It just indicates how actually bad we manage our planet. Let's say good maybe for us, but bad for nature. And again, it's not only nature, I mean wild nature. Yeah, look here. It's the typical, unfortunately, typical picture the atmosphere in Beijing, it's before the pandemic situation. It's mask not for pandemic, but for COVID protection. It's from actually for air protection. It's again not only the situation in Beijing. Unfortunately, in many megapolises, in many cities, we have more or less similar situation. Sometimes, again, industry is not so friendly for the environment. And that is why, starting maybe from 1970s, the United Nations developed this great strategy, sustainable development, what we should do to live a long, happy life from generation to generation. And now we have this Agenda 2030. Starting from 2015, the United Nations proposed again sustainable development goals, very bright, very, let's say, idealistic, world without hunger, world without poverty, sanitation and clean water for all of us, gender issues, and so on and so forth. And again, today we realize it's idealistic, not so realistic, but for me it's a good idea to be so ambitious, yes, to be so ambitious. And in this way, the European Union may be one of the best, one of the strongest community, big European community, which follows this sustainable development strategy and sustainable development goals. For example, look here, just starting from the basic document, the Treaty of European Union, they indicate that their goals actually sustainable development of Europe, based on three components. It's my marks, but three components: economy, social issues, and environmental protection. Again, I guess most of you, if not all of you, know this strategy Europe 2020, when European Union, after the global financial crisis, proposed, Euro Commission and European Union accepted it, proposed a strategy for smart, sustainable, and inclusive growth. What does it mean? It means that they actually not forgot about these ideas, yeah, of sustainability. They applied it. For example, the great demonstration back in 2010, they proposed the target climate energy. 20% of all energy in the European Union, they wanted to be covered by renewables. 20% of energy efficiency should be increased in 10 years. 20% of greenhouse gas emissions should be reduced in terms of 10 years. And actually, by 2020, they reached these goals. It's again, it's a great example for all of us. During these years, they developed other, let's say, supportive strategies, and one of them, especially close to us ecologists, the strategy of circular economy, the strategy of this closing the loop. What does it mean? Look here, very simple idea. The business as usual, yeah, take, make, dispose, so-called linear economy. We take resources from the nature, we make some products, and we dispose waste in some time. And it's only a matter of time when all resources on the planet will go to the waste, unfortunately, yeah, unfortunately. And look at the natural ecosystem. During billions of years before us humans, Homo sapiens, appeared, actually, natural ecosystem didn't have the idea of waste. Why? Because we have this circle: producers, consumers, decomposers, and actually these food chains always consumed all the so-called biological waste from previous form of organism. And it's the idea of circular economy. We should plan our production, we should plan our industry, our agriculture in such way that we will use resources as long as possible, as effectively as possible, and we should produce waste as less as possible, and again, due to recycling, due to effective waste management, to return this waste back to the economy, back to actually normal usage. Okay, and actually you see it's the progress in waste management, because it's one of the key components of circular economy. I mark here the percentage of municipal waste which go to the landfill. And during a few decades, actually, the European Union decreased significantly this amount. If we have here in 1990s, maybe 60% of waste in landfills. Now they plan only 10% should go to the landfills, and other should be treated properly, mostly recycled. And for example, again, ambitious plan in Directive 2018, more than 15% of plastic should be recycled, more than 70% should be recycled in ferrous materials, and again, glass and paper, 70-75%. It's really good ideas. And finally, sorry, the key maybe strategy, the current strategy in 2019, actually, the then new president of European Commission, Ursula von der Leyen, proposed the ambitious plan, so-called the European Green Deal. The ambitious, why? Because by 2015, European Commission proposed Europe should become the first climate neutral continent. Climate neutral continent means we shouldn't produce waste more than we may recycle. We should have zero net greenhouse gas emissions. If we produce, we should treat, or we should restrict production. And it's really ambitious. Again, it was a lot of critics from experts, because 2050 it's really far from us. But nevertheless, it's a good idea to have such high ambition plans. And later, if this strategy actually was strategic document, not a binding document, in 2021, the European Parliament and the Council adopted the European climate law. And now this climate neutrality actually is mandatory. Climate neutrality is mandatory. It's a binding objective of the European Union to reach climate neutrality by 2050. Practical realization of these ambitious plans, for example, package from European Commission, a proposal, it's actually a package of proposals for European Union legislation, so-called Fit for 55. Fit for 55 means that to 2030, it's much closer to 2030, European Union plan to reach 55% reduction of greenhouse gas emission compared with 1990. Typically, it's compares with 1990, and 40% of all energy. 40% of all energy should be covered by renewables. It's really, really ambitious plan. We may compare with Ukrainian data. If you wish, I will demonstrate it. Okay, and again to the wild nature or generally for the environment. The European Commission in 2020 proposed that at least 30% of lands and 30% of sea water should be protected. I mean, this Natura 2020, this a huge protective network, they should cover at least third part of lands and sea, these protective areas. And again, it's a really ambitious plan. But look here, practical realization touch a lot of parts, sectors of economy, including farmers. For example, to reach these climate goals, they propose, the European Commission proposed that pesticides, chemical pesticides, should be reduced by 50%. Or, for example, organic agriculture without any chemicals should reach 25%. It's a really challenging issue. And unfortunately, not all members of society were happy. And you see this picture, it's farmer protests over the Europe. Unfortunately, here in Ukraine, we remember protests of Polish farmers on the border, Poland and Ukraine. It's hurts us. Why? Because we remember this great protection, great support of our Polish friends during these years of the war. Nevertheless, this protests not only against, let's say, Ukrainian crops, but against this European Green Deal policy. Unfortunately, it's not so kind of clear, not so simple in the European Union. And again, one more example. Recently, they failed actually to adopt the natural protection law, which were prepared, and actually which formalized all these demands on pesticides, on protective areas. And now, unfortunately, they are waiting the European Parliament election in summer and forming new authorities, European authorities. That is why, again, it's some challenges. But if we are talking about challenges, I guess much more challenges, not only us, Ukrainians, but Europeans, the European Union has much more challenges due to this terroristic Russia, terroristic behavior of Russian leaders, and this war, terrible war in the middle of the Europe in 2022, 2024. And again, just after the beginning of the war, in February 2022, 2 weeks after the beginning, you see March 8, the European Commission proposed in reaction on the beginning of the Russian aggression, they aimed to totally restrict their dependence on Russian energy resources, on Russian gas, because it's two important components. First of all, to restrict their dependence on Russia, and second, actually to restrict Russian potential, economic potential. And unfortunately, it's picture from this communique of the European Commission. About 45% of all natural gases at that time Europe got from Russia. It's a huge dependence, and they planned that during the year they should reduce by 2/3 this dependence on Russian gas. And actually, they proposed the idea of diversification. First of all, LNG, liquefied natural gas, and again, significant development of renewables. And for us, for ecologists, very important, for example, the idea of the European Commission, the European Union, to develop this biomethane production, biomethane technologies, and they assess that it may give over the EU about 35 billion cubic meters per year. It's a significant part. And again, even more, they plan to get from solar and wind energy. Actually, this 170 billion cubic meter, it's similar to all amount of Russian gas imported to Ukraine. Oh, sorry, to the European Union. So they actually may change significantly the situation, and they plan. Again, it's not so easy, and you see two pictures, two graphs. It's decreasing of Russian gas on the European market, and it's significant increasing of price of gas. Yeah. Nevertheless, today, for example, to the back of 20 and to the end of 2022. Russian gas had only 7.5% on the European market, compared with 45%. Now, unfortunately, it's about 15%. It's pipelines and liquefied gas. So Europe still use Russian gas, and we hope it's temporary. And the situation will change. In Ukraine, again, in Ukraine, we produced in better time before the war about 20 billion cubic meter of gas, and about 10 billion we imported. And again, our potential is huge in biomethane production. You see here assessment about 20 billion cubic meter of biogas we may produce. We may actually cover all at least imported gas. It's our future. But again, it's okay. We may do it. Europeans and Ukrainian communities may do it. But today, again, we have much bigger challenges, both Ukrainians and Europeans. I mean, citizens of the European Union, because this terroristic, not just war, but terroristic policy of the Russia, just a couple of numbers, it's official numbers, yeah? During these 2 years, more than 11,000 Ukrainian civilians were killed, just in the middle of the Europe, yeah? More than 11,000 civilians. And again, now about 40% of our GDP, of all our economy, works only to defend our country, from Russian aggression. About $155 billion we assess the destruction of our infrastructure. First of all, energy infrastructure. About $60 billion is the destruction of the environment. Later, we will have the report on actually these issues, including Kakhovska hydropower plant, and so on and so forth. This picture, you see, this kid, this child is smiling because he is happy. His home is destroyed, but his cat is alive. Yeah, it's a real situation for today. That is why, again, talking about sustainable development, we all in Europe are interested to stop Russian aggression, to change the, let's say, this order of world, and actually it's there may be today the most important part of sustainable development to solve this issue. And I really want to finish our thanks, permanent thanks to our armed forces of Ukraine who defend not only Ukraine but defend all the EU. Thank you, and I am done. As I am a speaker and I am a moderator, 2 in 1, I will ask if you have any questions or we are ready to go to our next speaker. Any questions? No. Okay. And Dr. Shepkova, are you with us?
Yes, I am. Good morning,
Okay,
Igor. Very nice seeing you, colleagues.
Yeah, very nice. Okay, so colleagues, Dr. Katarina Shepkova, Masaryk University, Czech Republic. She is a really reliable partners of many of us. So please, Katarina, the floor is yours.
Okay, thank you very much. I'm trying to share my screen. I hope you can see my screen. I hope it works for you. Okay. So, very good morning. I will try just to shuffle it a little bit because my camera is on the other screen, so I just look a bit weird to look at you sideways. So, Dobrý ránok. Sorry, my Ukrainian hasn't improved much over the years, but it's a great pleasure to be part of today's conference again. I think it's 10 years since we met for the first time, and I'm glad that after 2 years I'm back. And today I would like to tell you something about importance of our environment and surroundings as a key to successful implementation of sustainable development. I think what I have seen from presentation from Professor Yakimenko, I think I can build a bit more details on it. So, of course, you have seen that just 2 minutes ago about what definition of sustainable development is. But what I would like to dwell on and discuss a little bit more are really the pillars of sustainability. You know that there are 3 of them. There's environmental, economic, and social. And unless they are all of them in balance, then we are able to achieve the black part in the middle that is sustainable. And that leads us to sustainable development with all these criteria that are put forward. And of course, as it has been presented, there are a lot of lacks in all of those, in social, in economic, in environmental, currently in Ukraine. And it is understandable because you're fighting a conflict, you're fighting an aggression. So let me share with you some ideas. Of course, you have also seen this because Igor was mentioning what the European Union vision how the European vision of sustainable development has been translated into the EU policies and into the upcoming legislations, and some of them were mentioned. It's not only about becoming climate neutral. It's not only to look at the biodiversity loss, and it's not only to recycle or do circularity in our economies, but it's also to not leave anyone behind, to help inclusive transition to new methods, and also to address concerns of the European citizens. And I'm not only talking about the European Union, but I'm talking about broader Europe. This figure has also been shown, and I hope actually slides are moving. Are they? Can you confirm that the slides are moving, please? Igor, can you confirm? Or you still see the first slide? You can see the slides. The slides are moving.
Yeah, exactly.
Yeah, okay, good. Thank you very much, because in some instances it doesn't happen. So please, if there are any discrepancies, let me know. So what you see on this slide are 10 important components, 10 important policies that are implemented by different European directorates of the European Commission. There is not only the Directorate of Environment, but there are DG Agriculture, there is DG Energy and Climate, that are all responsible for their own sector, and they translate what has been said to be done into legislation, and some examples were shown in the lecture or given by Professor Yakimenko. But what I want to really show is leaving no one behind, and that means also within Europe, but outside Europe. And in addition to this, there is also a very important component of EU as a global leader, where the European Union really tries to be active and to show by its own example that there is a possibility to translate and transit really from dependence on fossil fuels to some other ones, to renewables, and also to change its previous, let's say, directions, visions, technologies, and to improve them. Of course, it's not easy, and I would like to focus solely on chemical and pollution examples. What you see here is the outcome of a survey that has been done before the European Green Deal has been published. So we are talking now about 2019. And it says that 84 Europeans are worried about impact of chemicals present in everyday products on their health. And also 90% of Europeans are worried about impacts of chemicals on the environment. So there is really, despite the European legislation being on chemicals management and pollution being one of the strictest in the world, the European citizens are still concerned. And they do have right to be concerned, because what you see here is so-called chemical iceberg, because we only have detailed information about this top white part, which, if you see that we have about 100,000 chemicals on the market in Europe, in the European Union, we only know, and we have studied extensively, about 500 chemicals. And for the rest, the darker the color, the less information and understanding of all potential impacts, be it physical, chemical, health, chronic, long-term mixture effects, we don't yet know. So there is still a lot of work to be done. And that's why the European Union has put together a European strategy where the European Union is trying to upgrade its legislation in the chemicals field to really prevent any further harm from chemicals to be released from manufacture and use at the European territory, but also during the chemical life cycle, during the times that the chemicals are no longer used and the products that contain them are being disposed of, become waste, or being recycled. So all this, of course, takes time. Now, my next slide is something that you may recall from 2 years ago when we had a fourth conference on sustainable development. And yes, there is a change. Last time when I spoke, it was in April 2024. And now it is of course, no, sorry, it was in April 2022. And now I'm speaking to you in May 2024, and it's 812 days after the aggression has started. And while previously I said that life of many has changed, in fact, it's life of all of us in the European territory have changed, and we all have to adapt to new realities. But of course, we don't forget that at the back of our mind, what we are trying to achieve are the balance between social, environmental, and economic pillar, so that we can effectively achieve the sustainable development. But it's true that in the middle of the conflict, we change our personal priority list. We want to survive. We want to make sure that our friends, family, ourselves are safe. And then everything else comes as a later priority. But what is important to recognize that the previously set principles and visions are still valid. They continue. We are still trying to fulfill them, even though the actions may be delayed. And I also want to say that notwithstanding the tragedy of any conflict and strength of any aggression, humanity has always persisted, adapted, and became more resilient. So even though there are extremely hard times now, and we hear a very different news, depending on, of course, what news agency are you listening to, it may not seem as bright, but it's not as dark. There is always a way forward, and there is always support around you, even though it may not seem fast enough, big enough, long enough, but it's there, and it will continue to be there, because we all need to succeed to be able to come back to the path towards the sustainable development. So if we look at it from broader path, what sustainable development challenges we have, the previous lecture said what the European Union stated, which changes it wants to make because it reacts to the crisis that hinder the sustainable development, and that's the climate change, nature and biodiversity loss, and also extent of pollution that is around the globe, and that's the global level. And all of these three challenges have to be addressed in an integrated manner and urgently. But we've realized since 2021, when the triple planetary crisis title was used for the first time, that we also have to address other things in the same integrated manner and in even higher urgency. And that's the restoration of peace. There are social inequalities which are growing in different parts of the world, but also to be mindful about overconsumption by our Western civilization, if you want, of resources, biodiversity, and energy. And that brings us back to triple planetary crisis and also to overproduction of waste. Well, what do we know about environmental challenges in Ukraine? And as I have seen the agenda of this conference, there will be a number of different talks in different sessions addressing this. But what I want to say, Ukraine is a large country. It's a beautiful country, which has a very different geoclimate, geography, a lot of waters, a lot of nature, a lot of beautiful environments. And sadly, a lot of it has been severely damaged in last 812 days. And what I would like to share with you are the results of a survey done by my colleagues, by Professor Ivan Holobek and by Dr. Volodymyr Chetverikov from the Gas Institute of National Academy of Science in Ukraine. I will be presenting some results of their survey that was done in 2007 and then repeated again in 2017 and 18, and also compared to what we know now. And maybe to show you then later on what are the other tools, what is other situation, that what we can do, how we can address. So if I continue further, this activity or the surveys that have been done have been conducted partly with the external aid, with the global project or support from the Global Environmental Facility, and they have been taking place in 2007, this 2017 and 19, and in 2019 we also started a project that should do a really large inventory. But for obvious reasons and for changes in the Ukrainian society, we had to put the project on standby, so we cannot continue right now. So if we only look at specific cluster of chemicals that are polychlorinated biphenyls and persistent organic pollutants, which by their physical-chemical properties are persistent, toxic, a lot of them are carcinogenic, and they are very harmful to both environment and health. We can say that in 2007, in Ukraine, there were more than 4,240 tons of the polychlorinated biphenyls. And this was only, I would say, lower estimate, and the experts estimated that the real amounts would be up to 3 times higher. When the same inventory was made 12 years later, the same amount, tracing back really the pieces of equipment, have revealed that there are about 2/3 which have disappeared, of which there is no trace. We don't know what happened. Were they dismantled? Were they destroyed? Was the content dispersed, released into the environment? We don't know, but it's a big concern. Similarly, and of course, this is what we know, that formally the location of this equipment, the huge metallic cases that contain the oils that are used for transforming the energy and that hold the energy infrastructure, where in Donetsk Oblast, Dnipropetrovsk, Zaporozhye, at Crimea, so in the places where there was and still is the high concentration of industries, steel, energy-making industries. And of course, you've all heard that, what happened, the conflict, the bombing, the destruction. So there, unfortunately, what we know is that a lot of this equipment was irreversibly destroyed. And there's not only loss of the equipment as such, but there is also environmental consequence, because it's not only the content of this equipment, but also addition of the ammunition, of other chemicals that were released to the environment because of the fires, because of the destruction. Similarly, the inventory done for pesticides, and I think that might be something closer to your world, is again, when the inventory was repeated 12 years later, almost 2/3 of the chemicals that were previously inventoried as being accumulated somewhere in the warehouses have been lost, have been destroyed. Have they been landfill? Was it environmentally sound? Well, we don't know. We cannot say. And at present, it is extremely hard to investigate. We cannot find it. What we know is also, and this is a picture that is unfortunately looking at the destroyed site of energy, water, and other infrastructures, and where we can expect a large environmental damage. So in any conflict, the greatest potential risk of environmental pollution is stemming from chemical and metallurgical facilities, chemical and radioactive waste landfills for all environmental compartments and humans. And this is what we see, and this is what we see what was lost. And I also want to add that the problem is not only the fact that the chemicals were released to the environment, but it's also that they can be transported once they have been released to the atmosphere by particles. They can be transported elsewhere. And it is crucially important to know and understand what is happening. So it is really important, and I know that some of your colleagues of your environment ministries and inspectors and some research institutes, they're trying to monitor the environment, and there are also some external networks that are trying to do the same, to at least estimate, if not possible, to take up the environmental samples, what chemicals and what is their quantities is currently in different environmental matrices. So, well, but what we need not only to try to document what is happening, but we also need to prepare for the future, what needs to be done when the conflict is over, and when we are finally able jointly to help your country to reconstruct. And it's not only about reconstructing the visible damages and, you know, building back the infrastructure, but it's also demining, sexual pollution inventories, what really happened, how much is in disposed of and what we need to do to remediate. And there, of course, the huge environmental problem will be demolition of the waste disposal from all damages on buildings, cities, villages, energy, water, waste, and other infrastructures. And all that needs to be remediated. And of course, health impacts need to be studied. So, of course, those two come hand in hand and they are the most visible. But these ones are also crucially important so that we can restore, at least partly, restore what can be restored, because some damages are sadly irreversible. What I want to share with you also is a study that shows that even if you have a severe environmental problem and if you tackle it, you can make a change. My country, the Czechoslovakia at the time, was the 6th largest producer of polychlorinated biphenyls in the past. And this chart shows you how much of those chemicals were produced. And as you can see, about 2/3 of those were sent for export. So they were not used in our territory. Nevertheless, we know that when the first survey on human health was performed, the citizens of Czech Republic and Slovakia have had up to 10 times higher levels contamination in their bodies of polychlorinated biphenyls. And over the years, we were successful in decreasing this consequence, as I'm showing you now. So this is the survey that was done in early 2000, where we have dioxin-like PCBs. I mean, Ukraine also had high levels. But when we look at the indicators, PCBs, these two highest bits are by the Czech Republic, while Ukraine is, and I cannot find you, but it's here. So you can see it's less than half of the impact that was on the Czech Republic population. Over the years, and that, of course, the chart is very busy, but we were able to decrease by actions of remediation of the environment, by really trying to remove the sources of pollution of PCBs. And we are only talking about one chemical. And we have succeeded. This lowest peak is from 2019. Of course, you can see then the rest of the world is still much lower. But comparing where we started and where we are now, we are at about 1/10 of the formal concentrations. So what I want to conclude, because I know that my time is up, is that to move forward with sustainable development, we need to cover all 3 pillars and end conflicts, have infrastructural repairs. But in order to be successful and in order to be able to restore the balance, we have to have documentation of the impact and damage from the conflict so that we can plan the most effective remediation of the environment. And I'm glad that the Ministry of Environment and Ministry of Defense of your country is doing it, and they are publishing daily maps and they are trying to document as much as possible. The tool exists, but what we also need quite urgently, we need that there is a new expertise and young generation expertise is built. So I'm really talking to all of you, current students, that we and your country will need your help to be able to remediate. And I would like to close that there is external help. There are countries and companies are getting ready to help you to restore your country as soon as the conflict ends, and to be able to help you in restoration in all of the pillars. And with that, I would like to thank you for your kind attention. And also I would like to acknowledge the huge work done by Professor Holobek, by Dr. Vladimir Chetverikov and their team, including the current Minister of Environment, Ruslan Strilec. So thank you very much. That's all from me.
Thank you, Katarina. Thank you. So thank you for really deep report. Please, colleagues, any questions?
Can I ask? please?
Yeah, please.
Thank you, Katarzyna, once again for a very bright presentation with very, very impressive numbers. And what the question is, what were the most active pollutants of PCBs back in Czech Republic, in Czechoslovakia, in Czech Republic and Slovak Republic?
It's both, yes, it's both countries. The most active, you mean from the persistent organic pollutants or PCB?
Like we know Škoda factory. Is it? Does
Okay,
it belong to the
polluters.
most active pollutant?
Actually, not
Polluters,
really.
polluters.
The most significant, the PCBs were also used in paints. So there was a paint making factory in the middle of Moravia, not so far from Brno, which has produced a number of paints that were used for outdoor and indoor purposes. But I think that the problems was rather not only the company itself, but also the chemical companies, two other chemical companies which used PCB in their oil. So regarding the PCB, it's not about industry or steel making industry. It's not the activity of the industry, but it's rather of its infrastructure and bad state of the infrastructure in late 1970s and 80s, where the capacitors and transformers were leaking. So in some instances, the soil was polluted, and then the secondary releases happened to the air, and then the pollution spread into waters, and then it was followed further. But what I can tell you that in Slovakia, by far the highest polluter is the former producing factory in Chemkostrajské in the eastern part of Slovakia. And that has not been remediated yet. Only the remediation started 45 years after the close down of the factory. And I spoke to the Slovak minister or deputy minister in April, and he announced that the tender for removal of first drums containing the PCB were actually happening today. In the Czech Republic, we have succeeded in remediating most of the really highest polluted sites already in early 1990s, and by 2006, so it's almost 20 years ago when we have done this challenge. But I think that the biggest challenge for Ukraine now is that basically all the closed facilities that were in Ukraine in steel making industry, energy making industry, the high transformers and capacitors have been destroyed, and their content has been released to the environment. So basically the soil around it is highly contaminated. So the only way how to remediate this pollution will be to remove the soil and clean it, or making sure that it is safely, it's removed and it's safely caged, so that it cannot secondary releases cannot take place.
Wow, thank you really much. Unimaginable amount of work is to be done in
Huge.
future.
It's for decades, but it is manageable. It can be done. And it is important for all of us, because once there is secondary release to the air, the air circulates around the earth, so it will come back to all of us. It will not only be the immediate impact in the surroundings of the destroyed facilities. So we have to do something about it, and I know about many companies and many countries who are ready to support you.
Okay, thank you, Sergey, thank you, Katerina. Other questions? Okay, if I may, Katerina, back to this good example of PCB control, yeah? What do you think, or what do you know? It was more change, the first stages, yeah, of improving the situation. It's legislation, new adaptation of more strict legislation, or just strict following the rule. I mean, again, thinking about Ukrainian situation.
Well, you have to have both. You have to have more components. You have to have not only the legislation that allows you to take stages and be strict and tells you what you have to be done. But you also have to have monitoring in place. So in our case, it was really helpful to have established air monitoring, to have established also food basket monitoring, so contamination of the food and feeds that we had to follow to demonstrate any changes and to be able to identify hotspots. So for us, we have legislation in place. I think Ukraine also has legislation in place because you are party to the Stockholm Convention. So it is embedded in your legal system. So the rule is there. All you have to do is, well, is to implement it. But of course, now I understand, not now, I understand that there are different priorities, but your field is ready. You can go straight to the actions of remediation because you can do that. You don't have to delay the actions once this is possible.
Yeah, thank you, Katrina. I am actually asking in long term, in long term perspective. And again, one more question. It's interesting for us in the EU directives, for example, for air pollution. You control only 12 most important pollutants. Compared with Ukraine, in our documents, we have maybe 500 of them, And I always explain to students that maybe they control only key stuff, something like that. Maybe it's other issue.
No, it's different. It's actually slightly different. In the air pollution legislation, there is focused already on the traditional ones, but there is then a specific legislation that you need to read in addition to this one, that control, for example, the persistent organic pollutants, which also have to be controlled in the air. So I think the amount of chemicals that are controlled is about the same. Only it is difficult to know where is the placement. You don't have them in apparent piece of legislation. You have them in different pieces. Okay. So you need to reach much more text to get to know all the details.
And again, sorry, I want to use this opportunity. For your opinion, how different may be the legislation of let's say, the EU and national legislations in member states?
It cannot be different. In the EU legislation, if it is directive or regulation, it's binding the same way in every member state. So it has to be the same. The only possibility for a member country is that they can be stricter than the EU legislation if they want. But they are stricter. They cannot go below the EU limits. So they can impose stricter limits, but cannot make it easier. And so
do they practice to apply strict regulations, or typically
some of them do? Like for example, in the case of mercury, in Sweden and Finland, they have like zero. They really have like zero mercury attempts, or in Austria there are some. So for some specific chemicals that the country finds as a priority, they can apply stricter limits, but otherwise they have to adhere, all countries have to adhere to EU limits. And if if the limits are not kept, of course, there is provisions in the legislation that the polluters has to pay. So there are fines that the polluters need to pay. And if the country is not fulfilling, then not that European Commission or the European Union agencies would fine you, but there are the ways how, if country is not complying with the outcomes, how to either help or how to make changes is if, for example, the supporting legislation in the country that would implement the measure is missing. So it exists. The limits have to be, as I said, the same or stricter, and the implementation is controlled by national inspectorates and organizations.
Okay. Thank you, Katarina. Thank you very much. It was a real pleasure to see you and listen to you. Yeah, thank you to be with us.
Likewise. I hope it was
Okay.
understandable and it wasn't too fast. And of course, I'm ready also after the conference. If there are any questions, please don't hesitate to, to send an email. Thank you very much,
Okay.
and Slava
thank
Ukraini.
you. Yeah, Heroes Slava. We will contact you. Yeah, thank you. And colleagues, thanks our previous speaker. And now I have a pleasure to introduce our next speaker, our colleague, our friend. It's Dr. Igor Kurachkin from Japan, if I'm correct, Sysmex company. And I hope, Igor, you are with us. Yeah.
Yeah, I hope you could see me. Yeah, you can see me. Could you hear me?
Yes.
Yeah. We can see you.
Can you see me? Yeah. And you can see me, yeah?
Yeah, we see,
I hope I could
but
share.
yeah, please.
Not my presentation.
No,
Just a second.
your
I usually use,
presentation,
yeah, I use Teams, to share. And
yes.
can you see it?
Yeah. But not full screen.
How about now?
Yes, perfect.
Good. We use here Teams, not Zoom. That's why I'm not really familiar.
Okay.
Yeah. Okay, thank you very much. Hello, everyone. My name is Igor Kurachkin, and first of all, I would like to thank organizers for this meeting for inviting me, and especially Professor Igor Yakimenko, whom I haven't seen, I think, for 34 years, if I'm right.
Hello.
I left Ukraine in 1990. Yeah, nevertheless. So it's a pleasure for me to talk today and talk about this relatively new and exciting field of research, and not only research, as you will see, titled Diagnostic and Therapeutic Potential of Extracellular Vesicles. So these are highlights of my talk. And I would like to start with presenting my account, how I actually myself got interested in this field. So one day I was just looking through the content of Nature Cell Biology. It was in 2007. And I came across this paper, exosome-mediated transfer of mRNAs and microRNAs is a novel mechanism of genetic exchange between cells. To be honest, before this, I even didn't know what are exosomes. And when I've seen this, I was surprised. It turns out that cells secrete small bubbles, vesicles. And in this paper, it was shown they could identify 16,000 messenger RNAs in these vesicles. More than 1,000. Some were enriched in these vesicles compared with donor cells. And they found not only messenger RNAs, but also microRNAs. But more interesting, when they added these vesicles from mouse cells to human cells started to synthesize mouse proteins. That suggested these vesicles may change genetic information in a very functional way. So then I got interested in this, started to read literature, and it turned out that time was not really many papers about that. And it turns out that they were accidentally discovered in 1940s, this small bubble secreted by cells. And then we have platelets, in blood, and they found to be secrete also vesicles, which were called platelet dust. And then it was quite silent, this field, until 80s, when cell and molecular biology got some quite of significant development, and people got interested in it. But then again, it was a quiet period, and up to, maybe we can say up to 2007, until I read this paper. And then a couple of papers around 2007 appeared, which also claimed that those bubbles secreted by cells contain genetic information in form of mRNA and microRNA. And I would like to show this 80s papers from several groups. Why is it interesting? Because people at that time saw these vesicles. Here you can see them being secreted from reticulocytes during maturation. But they thought that function of those vesicles was just expelling garbage bags, because when we know they work as garbage bags, because platelets on maturate, they have to read off transferrin receptors shown here in black dots, this electron microscopy picture. And again, people were not interested. Okay, some vesicles secrete some unnecessary materials. And then after this paper, which I mentioned, 2007 paper, you can appreciate here the number of papers, a number of original papers shown in blue, just exploded exponentially. So this is around this publication, 2007, and you can see number of paper grows now. This field is really now really exploding with many new researchers coming from different fields of research. You can find here even engineers and biologists working in different fields, not only in animal cells, but work in microbiology and so on. And very quickly, in 2012, first meeting took place, and International Society of Extracellular Vesicles was established. I happened to take part in 12, first meeting, and recently this meeting finished actually last Sunday. And you can see that a lot of national societies have been established in the recent history, and most European countries are there. You can look for, there is Austrian Society, Czech Society, German Society, and they hold annual meetings on extracellular vesicles. Also, you can see societies have been established in USA, Asia Pacific. So this field is really now like getting more and more popular. So this is basically what we know today, that vesicles are secreted not only by mammalian cells, they're also secreted by various bacteria, gram-negative, gram-positive bacteria. And they contain inside of them various molecular species, biomolecules, proteins, RNA, DNA, metabolites. And it turned out that there are three basic types of those vesicles. Those coming from endosomal compartment, from internal compartment of cells, they're called exosomes. This is actually was most popular term for these vesicles until recently. Microvesicles, which bud from surface of cells, unlike exosomes coming from endosomal compartment. And apoptotic bodies, you perhaps know, these cells before they're dying, they secrete pieces of cells, especially you can find it in dying cell, cancer cells. And it turned out that those vesicles have different sizes. By the way, could you see this right part of my slide? Okay, because is it okay? Yeah. Okay.
Yeah,
View. Okay. Good. But it turned out that the picture is much more complicated. Just in the recent few years, we found that what we call microvesicles, which bud from outside of cell membrane, in fact, have a lot of different structures, even morphologically. For example, microsomes were discovered just a few years ago, and they formed by cell extrusions, and many more you can appreciate on this slide. And exosomes also have different varieties, exosomes, those coming from intracellular compartment. As I mentioned, vesicles contain lots of all species, molecular species you can imagine that are present in cells. But important point, these vesicles were found in blood, in cerebrospinal fluid, in saliva, in tears, actually in all biological fluids examined so far. And yeah, my interest was in RNA content of those vesicles, and if we found that things not that simple. For example, we could not find full-length mRNA in these, very rarely. We would see rather fragments, and not just fragments, but those coming from 3' untranslated regions. This was confirmed by other studies. So it's interesting, it contains pieces of RNA. Whether it represents some hidden code or it's just product of degradation, we don't know. And it turned out that vesicles produced by different cells have a common components. You can see it in the Venn diagram shown here. But they have also unique proteins in this case, which is good because, for example, if you look at stem cells, cancer cells, immune cells, they have distinct proteins inside. And so you can imagine by analyzing those vesicles, you could perhaps have an idea what happens to the donor cells, cells that produce them. And scientists very quickly realized this. And 2008 was already first paper where people could detect glioblastoma cancer, deadly cancer in human brains. They could detect in blood. So they could take blood, isolate vesicles, and detect EGFR, it's a carcinogenic mutant in blood, in vesicles. So you don't need to do a biopsy, you don't need to brain operation in order to detect glioblastoma in a patient. And the next paper was interesting, published in Nature 2015, which shown that you can detect pancreatic cancer at very early stages. And you know, this is a huge problem because when people come to doctors, it's too late when you have pain. And imagine we could have a blood test and regularly, non-invasive, for pancreatic cancer. And this work, they claim they could detect pancreatic cancer marker DPCAM1 just by analyzing extracellular vesicles in blood. But if you look today at approved tests, today we have on market only one single test. And it's already, you can find in clinic in the United States. It's called ExoDx prostate test. And basically, it's very useful because, you know, men after 50 have very often PSA, prostate-specific antigen, which suggests cancer. And people have to undergo biopsy, which is a painful and often necessary because people may have not cancer. And with this test, you can say almost for sure, it's just urine-based test, vesicles presence in urine, whether people need biopsy or not, by analyzing only 3 mRNA. So you can see already some practical outcome of this field. And, you know, traditionally we use biopsy to detect cancer. You have to cut tissue, you cannot do it often, it's a painful procedure. But imagine you can analyze cancer through presence of cancer stage through saliva, urine, blood, or breast milk analysis. And today, before extracellular vesicles came into the light, people used circular tumor cells. You know, maybe it's also now exciting field of research when you have tumor cells circulating in our blood. It's exciting, but catching those CTC, so-called cells, it's very hard because they present very minute amounts in blood. And people also analyze now circular tumor DNA, which is DNA coming from tumor cells. And there are special techniques to detect it despite low presence. And exosomes add another layer or another opportunity to detect cancers in non-invasive way. The slide shows advantages of so-called liquid biopsy with traditional tissue biopsy. So it looks like we could detect maybe cancer using blood, purifying extracellular vesicles, but things are not that simple. We know that cancer cells secrete huge amount of vesicles compared with normal cells. That's why we can detect cancer cell-produced TVs even without enrichment. But even so, it's not very easy to get those vesicles in our blood because, you know, we have in our blood, in addition to vesicles, we have a lot of proteins, we have a lot of lipoproteins, HDL, LDL, VLDL, and they 5-6 order of magnitude present in higher amounts in extracellular vesicles. So it's not easy to catch from them. And the problem is that 99.8% of vesicles in human blood actually coming from blood cells, platelets, B cells, T cells. So it's even detect cancer tissue produced TV is not easy. And only 0.2% vesicles, which you find in human plasma, would come from tissues, not blood cells. So it's not easy task. And many scientists resorted to affinity-based purification of vesicles when you use antibodies against tissue-specific markers to capture your EVs for isolation. We work in recent years for analyzing, our goal is analyze neurological disorders by analyzing human blood. And today, as you know, to detect some brain pathologies, you use brain scans, MRI, PET technique, by the way, which is expensive, $5,000-$6,000 for PET scan. You analyze cerebrospinal fluid, which is a bit invasive. People even go for brain biopsy in case of brain cancer, or neurological exam, which is not really precise, let's say, for neurodegenerative diseases like Alzheimer's disease. So goal of our research to develop blood-based tests for neurological conditions. And it is known that some vesicles really can come through blood-brain barrier. And we think if we can capture those vesicles selectively from blood, we could analyze not only Alzheimer's disease, but many other neurological disorders. You can actually imagine that we could analyze any disorder associated with neuronal cells, just analyzing vesicles present in blood. And in our approach, we actually target neuron-specific molecules to capture those vesicles. And this is image of our diagnostic test that we would like to realize. And we see we start from brains and we collect blood. Then we develop technology to selectively capture neuron-derived EVs. And in our analysis, we analyze various proteins, including synaptic proteins, some proteins associated with neurodegeneration, also some RNA. And the purpose of this test would be diagnosis, blood-based diagnosis. You can imagine it's easy to do. Everyone can come to clinic and during general health assessment, do this test. And also during clinical trials where people would like to assess drug treatment response. And the idea to use our instrument produced our company. This is not advertisement, but we produce good instruments and we would like to analyze those markers. We are still this work in development. We haven't published papers on that, but we filed some patents on that. And things are not easy as at all because those vesicles, they look like vesicles. In reality, if you use electron microscopy, you'll find that those vesicles not just round and surrounded by single membrane. No, sometimes they're multi-layered. They have multi-vesicles inside, or they have a lot of strange shapes and structures. This is our data. We also saw many strange vesicles. But people notice that when you treat cells with certain, in this case, LPS, they treat monocytes, they see that these multi-layered vesicles start to appear. So maybe there is some physiological significance. And this recent review, they proposed some idea how these vesicles appear and what the function might be. But even at this, I want to say, even morphological levels are really different. But when people started to use various techniques to analyze surface of those vesicles, the shape, size, and internal content, using these methods shown here, they found the really huge number of vesicles, and they differ not only as shown here in the surface molecules, but also in internal content. This could be different RNA, different proteins, different metabolites. It's schematically, symbolically shown here that almost like every vesicle is unique. And you can imagine if you go for diagnostics or for therapeutics, we have to know what we work with. And things not easy. And therefore, to purify just vesicles is not difficult, but purify certain subpopulation is challenging. And therefore, there are many methods now. And this field is evolving. And there are methods which involve some large instruments or microfluidics. It's really evolving field. And also there is demand for single EV analysis because, as I mentioned, all EVs or EV subpopulations really truly different. And it would be nice to analyze not bulk population of EVs, but single EVs. And this is now really evolving field. Many new startups now appear which analyze those single EVs, and they hope they will get even commercialized with good profits because once we develop simple techniques for analysis of single EVs, you can imagine we could develop new diagnostic tests. So because of variety of those vesicles, lots of work published now, like every day you see new papers published, there is a problem with standardizing this field. So people in paper describe experiments and others cannot reproduce. That's why some guidelines were worked out, and it was 2014. First guidelines. I happen to be one of the authors on this work, and these guidelines evolved, and recent guidelines, I would want to say, involved more than 1,000 scientists. If the paper was published this year, 84 pages, and it took 3 years to develop these guidelines. So if you're interested in vesicles and you need a good review of this field, just read these guidelines. It provides really nice overview of the field. And how about, it was noticed that EVs coming from mesenchymal stem cells, from iPS, induced pluripotent stem cells, have therapeutic potential. When they add, for example, to heart of mice or pigs after heart infarction, vesicles produce mesenchymal stem cells, they had less scares, they had less deaths, and so on. And this is very recent work when EVs from platelets can be utilized for wound healing. And then people realize that you can use not only vesicles, they are not themselves have therapeutic potential, but you can engineer them. You can actually introduce to them either endogenously or exogenously various molecules. You can imagine it could be some therapeutic mRNA, microRNA. This could be vaccine, like we recently, you know, this COVID vaccine when mRNA was encapsulated lipid nanoparticles. This is also how we really, again, lots of startups there. Just an example. This is about Singapore group, which published paper 2018 about efficient drug delivery using red erythrocyte EVs. And you know that erythrocytes is the most abundant cells in our body. They have huge number of erythrocytes. And they found that if you stimulate erythrocytes, you have huge number of vesicles. And then this group developed some engineering approaches to incorporate to this erythrocyte EVs various therapeutics, proteins, RNA, and just see how what happens. They could use CRISPR system, and it worked on mice. And Takeda, you know, Takeda Pharmacy, large company, offered them $900 million in total milestone payments plus royalties, just for this technology. So because it holds a big promise. And now I will soon finish my talk, because many of you come from food technology university. Maybe for you will be interesting that cow milk extract vesicles could be used for effective oral delivery of drugs. So previous slide shows this erythrocyte EVs, but it was shown that you can incorporate various drugs, various molecules with therapeutic potential to milk EVs. It's an interesting field. And more, when people analyze plant EVs, they found that extracellular vesicles produced by fruits themselves have anti-inflammatory effects. They even used in treatment of polycystic ovary syndrome. Those from ginger or EVs from ginger or aloe. This is just a sketch from a recent review. Also interesting, lots of scientists started working on it. And you know, our food, when we have food, it contains actual nature, a lot of EVs coming from plants, from various organisms, even like you can think fermented food. When you have fermentation, you have microbes, they secrete vesicles. By the way, we have, in our gut, we have, you know, a lot of microbes. It's a field for microbiome research. We have hundreds of species living in our intestine, you know. And they secrete vesicles, and these vesicles actually enter our bloodstream and communicate with our body. It's an interesting field. And even there is a hypothesis that when we get Parkinson's disease, it actually comes from our gut. And those synuclein aggregates, actually, they come to bacterial EVs and come to our brain, and then they develop full-blown Parkinson's disease. So food-derived EVs, it's, again, because you're in food technology, interesting thing, because they found that many effects of food actually are due to EVs present in food. And it makes very important to develop technologies, keep food properly, because upon some treatment or improper storage, all these beneficial effects of those EVs and food are diminished or disappear simply. Also, nice application. And yeah, so, you know, recently all drug development delivery was based on lipid nanoparticles. You know, recent COVID vaccines, you got this mRNA, it was encapsulated lipid nanoparticles. This is standard way. But you can see that just in recent years, delivery by exosome shown here in red actually is used more frequently, maybe for research, than in those particles. And various applications of EVs shown on this diagram. You can see here diagnostic application, therapeutic application. Many of those are in clinical trials, from starting from early phase 1, and some even now entering final phase 4. And this is expectation for growing of this EV-based diagnostic, therapeutic, and research market, money for research. And these diagrams are presented by different companies. I should say they're quite different in their numbers, but all of them suggest that this field is growing rapidly, and investment shown here. And now, to summarize, we know that our body contains different systems: circulatory, respiratory, immune system, and so on. And perhaps vesicles, when they circulate our body, exchange information, they present new, we can call it informatory system. And maybe it provides genetic information exchange between human organs, between our organs and gut microbiota. And maybe they serve as information gatherer about the state of the whole body. We don't know. Or maybe they have control of information flow in our body. And this is a very recent paper that EV exchange was found even between cells in the sea. So even organisms with some complex ecosystems maybe coordinate their behavior and actions through exchange of information via extracellular vesicles. And now I would like to recommend you to know more about EVs, to visit International Society for EV site. This is a major site, and they have very nice educational tools, 1, 2, and 3 recently developed. This is absolutely free. You can see very nice video given by really good specialists in the field. I also would like to recommend you go to YouTube. They have, the society has a page, more thousands of subscribers there. They in advance usually announce some new talks, presentations, and you can attend in live talks and ask questions to presenters. Nice tool. And this is conclusions from my talk, but basically major things. EVs are produced practically by all cells, all living cells, animal, plant, yeast, bacterial cells. They contain a lot of information there, but basically everything you find in cell, you find in extracellular vesicles. They present in biological fluids like blood, urine, saliva, and making possibility of non-invasive diagnostics. They're highly heterogeneous in terms of morphology, site content, functions, biogenesis, and we still this field at infancy. And we don't know much. We don't know more than we know so far. And scientific findings are exciting, are expected in not only biology, but practical applications, potential practical applications of EVs are enormous. And with this, I would like to finish my talk. Sorry, I took more 5 minutes. I should. And thank you for your time. And if you have time, I would like to take your questions.
Yeah. Thank you. It's totally okay with time. It's a real, I guess, it's a real discovery for many of us. Your topic, yeah. Thank you very much. Very interesting. So, people, please, any questions? Any questions?
Can I ask?
Yeah,
Please.
Sure.
Igor, thank you for very interesting presentation and very really much of discoveries you described. One slide showed that LPS can be an inducer for the EV pattern. And we know that the LPS can be used and is to be used for polarization of macrophages. So is there any science describing the reaction of macrophages to LPS activation in terms of the pattern of EVs they release?
You know, I first of all, I'm not expert in immunology, so I cannot give you a very professional answer, but I just read this review on multilamellar EVs, and they hypothesize that when vesicles have many layers, they action on target cells somehow is prolonged, kind of this. I think it's maybe hypothesis. Sorry, I looked through very quickly, but you could go maybe through this review made by, written recently by Broad and others. It was published in Journal of Extracellular Vesicles. Maybe find more on this. I'm not expert, honestly speaking.
Okay, thank you. Very interesting.
Okay.
Yeah, that's an interesting field. Yeah.
May I also ask one question? First, I'm very glad to see you. I did not see you for ages.
Me too. Yeah.
Hello. And yeah, it's a very interesting presentation, very interesting biology, and also very good perspectives for applications. You mentioned in one of your slides that for drug delivery, extracellular vesicles perform better than liposomes. And
Oh yeah.
What is could you explain what is the difference between them and also the difference in the production process?
Yeah, one thing why they could be better because they're natural, those vesicles. So there is a natural tropism or like affinity to target cells. For example, if you just inject TVs and label it TVs with fluorophores, some fluorescent labels, and see distribution in bodies, there is a lot of such experiment. They all distributed immediately, very quickly to different parts of the body, mainly to liver, to kidney. Actually, it's a big problem because when people want to deliver specific drugs, they want to target, say, brain, but it doesn't go there, only a few %. So that's why maybe exosomes or cellular vesicles actually compared with lipid nanoparticles, they have a natural just affinity to some. They easily fuse perhaps with target with cell membranes. But you know, interesting thing, I show, I think in this slide that actually people mix exosomes, EVs, with liposomes and create so-called hybrid vesicles. So you can imagine it's easy now, it's already developed technologies, and in liposome you can incorporate a lot of molecules. And then you can fuse these liposomes, engineered liposomes with natural vesicles. And they create hybrid particles with both. They have advantage of liposomes, where we already have a lot of techniques for incorporating various molecules, plus EVs, which have a natural tropism, and they're basically non-toxic or minimally toxic. And lipid nanoparticles, I'm not sure they're completely not toxic or not, depends on the structure maybe. I mean, I'm not an expert. Well, one of the advantages, I think, it's a natural, easy uptake of EVs by cells, perhaps. And because also exosome naturally decorated with many perhaps receptors, which make it easy to fuse with some. You can engineer exosomes. There are many papers now. People engineer surface of EVs so they can enter some specific tissues. So perhaps hybrid vesicles would have also they have good potential. Hybrids between synthetic nanoparticles and EVs. I'm not sure I answered your question.
No, thank you very much.
Okay, thank you, Igor, thank you. One very brief question from food technology. Yeah? Do these vesicles survive in our digestive system?
Yeah, what actually I read is that actually the vesicles, for example, present in juices, different juices, they easily enter our blood flow through intestine, like no problem. It's a natural pathway to enter our body. I read somewhere. Yeah, they enter through intestines somehow, human intestines. And maybe food treatment or storage, I don't know, would affect properties of the EVs. So sometimes maybe we lose this useful properties because of improper or not suspected actually active components being present in those EVs. We just didn't realize it might be important to store properly food just because we store improperly EVs present in this food.
No, or maybe for drugs, for vitamins, something like that. It's very cool.
Yeah, maybe you can imagine you can incorporate in those EVs. And because if you look now at papers, most papers publish papers, these animal cells so far for therapy, they take human cells, culture them, incorporate some therapeutic molecules. But maybe it will be much potentially less problematic use plant EVs or milk EVs, those which don't have genetic information, which could be used for allogenic treatment for any person. Because now there is kind of therapy when they want to use your own EVs for your treatment only. This is nice, of course, produced by your cells. But you can imagine that plant EVs can be used for everyone, or milk-based EVs.
Okay, okay.
Actually, there are published papers already, you know, when people incorporate into milk EVs some maybe mRNA, maybe some drugs, anti-cancer drugs, and then become functional. They actually have therapeutic effect.
Okay, thank you, Igor. Thank you, thank you very much.
No, thank you everyone for your time.
Thank you. Okay.
I recommend everyone to start working on this. Either you're a food specialist or either you are a bacteriologist or I don't know. This paper about communication of microorganisms in the sea was really exciting, and it was profiled in recent news. Maybe that's why I catched it. I actually don't follow the information. This one on the exchange of genetic information between bacterial communities in the sea. Yeah, that's interesting. Yeah. For environmental, perhaps, environmental studies.
I am pretty sure a lot of us will touch you, will reach you.
I'm sure you will move to this field, all of you. Yeah.
Okay, yeah, thank you very much, Igor.
Yeah.
Thank you.
Okay, yeah, thank you again for inviting me. Yeah, for opportunity to speak today.
Yeah, thank you very much. Thank you.
Okay, слава Україні.
Yeah, героям слава. Героям слава. Okay, and we are moving forward, and colleagues, I see our next presentation from our colleagues from Denmark and Germany. The first author, Stefan, if I'm correct, Stefan Jr. Yeah, Stefan.
Yes, that's
Yeah,
fine.
okay.
Yeah,
Okay.
thank you.
Yeah, please tell your name, please.
Stefan Junne.
Yuna. Okay, sorry. Yeah, please. The floor is yours. Yeah, please.
Yeah, thanks a lot. Just sharing my screen. Just a second. That is the last slide that comes in a minute, and that's the first one. So, yeah, I will change a little bit the topic. Also, I will also talk a bit about microbial communities, but not so deeply on the transformation level, but actually a very interesting topic, how microbes communicate within the microbial community. But first, a few words about myself. So I was working for almost 12 years as group leader in bioprocess engineering at TU Berlin. That is the building you see here. There will be a talk in this conference later on from Peter Neubauer, who's actually heading this lab. And currently, I'm still attached to that lab. I have a work group acting there, still very active with a few PhD students. But since 1.5 years, I'm also working at Aalborg University in Denmark. But actually, I'm not working at Aalborg. I'm working 370 kilometers south of Aalborg in Esbjerg. That's a town you can see here at the North Sea, and that's where I'm currently in my office. And I'm glad to tell you something about how we can valorize mostly biogenic residues, which we have. We have tons of it, for example, in Germany. We have many million tons of bedding straw that is used for stables that is currently not used for anything. It's just put back on the field, and the degradation on the fields is taking a long time. And it is, for example, not used for bioenergy production. You might have heard that, and I, due to time and also the focus of this conference, I don't want to go into detail with this, but many countries, especially in Central Europe, they are facing big challenges currently because they are shifting from a rather gas and coal-based energy production towards renewable energy. But the wind is not always blowing. It's actually blowing a lot here in Esbjerg. So here we have one of the biggest offshore windmill hubs in Europe. Every day ships are leaving to the North Sea and installing more of those windmills. But still, there are times there is not much wind, so the power production is declining. On the other side, we have a very well-established biogas production in Germany, in Denmark. And the question is still, how can we increase the share of these residues which are unused on the one side, like bedding straw, and decrease the use of plants which can be used as food, like corn, crops. For example, maize silage is used to a high extent in those biogas plants. And on the other side, flexibilize the bioproduction. If we have a biogas plant, we have a stable production, but actually you can run this, it's a microbial process. You can feed it a little bit higher, so the microbes are converting more, so you can produce more energy. And on the same side, you can also reduce the feeding, and then you can reduce the production of methane, for example. But this cannot be easily done in a simple stir tank fermentation tank for anaerobic digestion. So you have to do something. And this is why we are doing research, a lot of research about microbial hydrolysis already for quite some time, and particularly in plug flow reactors. I'm on the next slide, I will talk more about microbial hydrolysis as such. But our idea is that while applying such a plug flow where you put in substrate on one side and then the substrate is degraded by the microbes to most of our short-chain carboxylic acids like acetate, we want to follow this degradation process and by this control it. And then at the end of this process, we will have intermediate products for whole digestion. We will have intermediate product that we can use in xenic cultures. I will show you one example where we use actually the short-chain carboxylic acids for further valorization for producing food components and additives. And we can, by this, also flexibilize the energy production. But let's start first with the hydrolysis. So in full anaerobic digestion, we cannot distinguish between the hydrolysis, the acidogenesis and acetogenesis, where the short-chain carboxylic acids are accumulated, and the methanogenesis, where methanogens are converting the short-chain carboxylic acids to methane. So that's what you see here is the classical anaerobic digestion path. But we are particularly interested in controlling these intermediate short-chain carboxylic acid synthesis, as by the change of concentration and composition of the short-chain carboxylic acid fraction, we can control whatever comes later, or we can further valorize this in xenic cultures. And what we are actually doing here, you see two of our PhD students. Teresa, she just accomplished her PhD. Now Mario is still ongoing. So they have been working in the past 3 to 4 years on actually trying to, first of all, control this microbial hydrolysis by several means. First of all, we are applying recirculation. So we are taking a part of the cell suspension, which comes out at the end of this plug flow hydrolysis or acidogenesis process, which comes out of this reactor. We are taking it back into the front in order to increase the microbial load in the front when we take, for example, bedding straw, which as such does not contain many microbes. It does not contain many hydrolytic microbes when it comes to us. So we just cut this straw and then we recirculate the suspension back. And by this, we are increasing the microbial load in the beginning so that the hydrolysis is starting at once. You can then recirculate this from different locations at this bioreactor. If you have questions about it, I'm happy to answer, but I don't want to go too much into detail about this. And we are using online monitoring to see how some of these online parameters develop along this plug flow reactor where we have the degradation of the substrate. Because the current situation is that people are using sometimes plug flow reactors in industry, especially for degrading household bio-waste in Germany and also in Denmark and some other countries. But usually the online monitoring is still very, very poor. And our aim is not to use very sophisticated, very expensive sensors for monitoring, because people will not apply it in that field. There's no way that I can tell somebody, hey, buy an instrument for 50,000 euro in order to control your hydrolysis. Nobody will do it. So we thought, what are cheap, well-established sensors in the market that can be applied? This is, first of all, the pH. That is the conductivity, and that's the redox potential. That are established sensors, and at least not all of them, but some of them are working well in an anaerobic digestion cell suspension. You can put them in, you don't have to recalibrate them for a year, so that's fine for even industrial application. But what nobody did, for our surprise, was nobody had a look at how actually these parameters develop in this spatial development or during the residence time of material in this plug flow reactor. So we did a lot of experiments under different loading conditions, where we mixed the substrate, the bedding straw, with other residues like food waste. Also, we always had a small share of energy crops, that is for stabilizing the microbial culture. And then we had a look, can we actually use these online monitoring values for controlling this otherwise rather uncontrolled process? And for this, and I personally find that also interesting, for this, we also made our own plug flow reactors. So that is something here, if we put away the sensor technology, so such a sensor still costs like 600, 800 euros. That's like a typical market price. If we take away these sensors, we are able to build such a lab scale 20-liter plug flow reactor, which we can operate continuously. This one was operated continuously for 3 years. We just in between, we took out the sensors in order to check whether they need a recalibration, offline recalibration or not. But otherwise, this reactor was running for 3 years, and it is made of 3D printed parts, a little bit of steel tubes we have here at the side and here, and then we have an acrylic tube here in the center. We are controlling the temperature with the water bath. Is this very nice for us? It takes us 2 weeks to get all the parts for such a bioreactor. We installed it at our lab. We installed it at, it was a European project. We installed it at partner labs, the identical bioreactor, without having much investment costs. But that is just a side info. So we used that reactor. We got a lot of data, and then we actually look at what can we do with the data. And what we also did is that we, from time to time, bio-augmented the culture we had in this plug flow reactor, because for us it is important to enrich the microbial community inside this reactor with cellulolytic organisms. Because if we have a certain straw load, then we need to have, for example, cellulases that are able to degrade this cellulolytic part of the straw in a considerable amount of time. Here you see some hydraulic retention times we are typically applying. So that are 7 days, 14 days, and 21 days. Usually we are now operating in other experiments also with a share of bedding straw of about 50% in the substrate. We are operating our hydrolytic reactors with a residence time of only 10 days. So we are not talking about these classical retention times in anaerobic digesters of 60 days or even more when people have used straw contents before. We are now talking about 10 days only, which allows us also in industrial scale to make things much smaller. yeah, or increase the throughput of the substrate. So, and yeah, by this changing the recirculation, changing substrate composition, changing or adding microbes. Here we added penny bacilli, and we also are adding Clostridia, several strains of Clostridia, in order to increase the amount of hydrolytic enzymes. We created very different operational conditions. And actually, unfortunately, I see now that's a little bit small here. Here you see the acid yield, and you see a variation and recirculation we applied. And if we took 2/3 of straw as input, we got an acid yield up to around 80%, while 100 is like what you can get out if you use just easily degradable substrate. So we are able with this setup to get out 80% of the theoretical yield in here it's 14 days. Now we are at a residence time of 10 days, which is first of all a nice thing. What are we actually getting out? So we are getting out, here you can see some of the acids. Here it's a lot of butyric acid. That is by purpose, because we need butyric acid for coupling it to oxenic processes. We have actually less acetic acid, which is also nice to have in there. And then in many ways you see like some other acids, but to a lower extent, which is actually very nice for us because, for example, we don't want to have huge lactic acid or pyruvic acid fractions, because that is not a very suitable substrate for either flexibilizing the methanogenic stage in an anaerobic digestion or using this as a substrate for oxenic culture. So we want to have a high portion of acetic acid and butyric acid, and this is also possible with this setup. And now back to our monitoring strategy. I will make a long story now very short, but if you have questions, you are please feel free to ask later on. So what you see here is again the total short chain carboxylic acid concentration. This is kind of what we are interested in. And here you see the conductivity. Yeah, this is the conductivity at a certain port. Depending on the state of the process, the conductivity measurements have different sensitivities, which means that if your process operates well, the conductivity at the last port is a very sensitive parameter. So it tells us about the completion of the hydrolysis. If we use a residence time that is too high, then in the center part we have a sensitive value of conductivity. But in both cases, can then use the conductivity for predicting the short chain carboxylic acid concentration, which means actually if we see a high gradient of conductivity between the inlet and the center, or the inlet and the outlet, then we also achieve a high concentration of short-chain carboxylic acids. That is for us a very suitable measurement because it's easy, it's cheap, and it seems to be quite reliable. Yeah, we are still doing it. These are continuous processes, so they are running in our lab. We're still getting more and more data. We are now coupling this also with machine learning tools, but that would be a separate talk. First of all, it's a very good sign. We can control the process to a certain extent with a very cheap and robust technology. But that's not all. In dark fermentation, what I showed you, so the hydrolysis and acidogenesis, if they are together, it's called dark fermentation. And it's called dark fermentation because people in former times were looking mostly at hydrogen production. I was not talking about this so far because we are mostly interested in the short-chain carboxylic acids. but also hydrogen is becoming more and more important to flexibilize energy production. So you cannot only feed a methanogenic stage with short-chain carboxylic acids, you can also feed a methanogenic stage with hydrogen. You can use, for example, hydrogen that is generated through hydrolysis by a surplus energy, which is especially a big topic in Denmark. When you have a lot of wind, you have a lot of energy production. And this is why we have very recently developed the first time, at least what we can see from scientific reports, we have developed a hydrogen sensor that measures dissolved hydrogen directly in the liquid broth. And then the idea is to further flexibilize the production, because we are adding hydrogen to the methanogenic stage, and together with the short-chain carboxylic acids and CO2 supply, more methane can be produced. In this sensor, because we are working, as you know, in a microbial community, there are always biofilm formers in that microbial community. So if we would take a membrane in there, people have done that, it's a nightmare. You get a big biofilm around it, and then you cannot measure anymore the dissolved hydrogen properly. But we need to measure the dissolved hydrogen in order to avoid strong hydrogen starvation or oversupply of hydrogen. And we also need to optimize the power input. So our approach was to use a membrane-free measurement, where we supply an overpressure of a gas phase here inside the reactor that is done by nitrogen flushing from the outside. And then hydrogen diffuses through this gas phase, because hydrogen has such a high diffusion coefficient that it just passes through. And then the hydrogen is measured in a metal oxide sensor plate inside a chamber that is repeatedly flushed by some gas, and then hydrogen is just the first gas passing to this metal oxide sensor. And by this, we are actually able to measure the dissolved hydrogen. And this is what you see here. So we are making here pulse additions of hydrogen. The red line is the measurement from our dissolved hydrogen sensor. The blue line is the measurement from the off-gas value, which is not so representative for the liquid phase in such processes, because you have layer formation and so on. And you can see here, we are able to see, here's the addition of hydrogen, here's the consumption by the process, and then we make the next addition again. Of course, we did a lot more measurements about the performance of the sensor. We have also published this recently, but also due to time, I do not want to go into detail here, because I want to show you the last part of the whole story, that is that we are using the short-chain carboxylic acids for the exenic culture. And how are we doing this? So we are using a part of the effluent, so the cell-free, not completely free, but let's say we use centrifugation, so we are removing the cells. Currently, we are still filtering it, but we aim to remove that step, as in industry it would require too much energy. And then we are using the effluent, which is enriched with the short-chain carboxylic acids we are using for the exenic culture. And we are producing, in this exenic culture, we are producing polyunsaturated fatty acid, which is a fish feed and a food nutrient. So, and this is, by the way, I forgot to tell you that is called docosahexaenoic acid. That is a C22 polyunsaturated fatty acid. And here you can see the amounts of milligram per gram cell dry weight we are getting with like conventional substrate, that is glucose, that is grown with a heterotrophic algae, so no light is applied, it's just grown on glucose. That is the classical process that has been commercialized. And then you see here the outcome of the different, if you would use single short-chain carboxylic acids, and this is the outcome we are getting with effluent. We worked with artificial effluent in the beginning because we just didn't have effluent from dark fermentation. And here you can see the dark fermentation effluent. And since we have so many components there, it's like a complex media. The output is actually much better with the dark fermentation effluent. It's truly much better. What is due to the dilution we have a diluted system. So we are reaching, let's say, 20 grams per liter of short-chain carboxylic acids in the effluent. So our QP is not that high in comparison, but it's still competitive, what we have. Yeah, that is milligram of product per liter an hour. And we are currently doing this in a continuous process with cell retention, where cells are harvested from time to time. This is done at TU Berlin very successfully, actually. So we can use the dark fermentation effluent for producing this polyunsaturated fatty acid. And this is a big valorization of the product. And we are able to replace glucose in that process. We did an economic and also life cycle analysis of this whole, about this whole process. This DHA, this polyunsaturated fatty acid, it can replace fish oil and fish meal, which is contributing to the overfishing of the seas. We have an increasing amount of aquacultures. Therefore, this price is also going up, but at the same time, we are facing sustainability issues. And by using the DHA from biotech production, from the algae, with this dark fermentation effluent, we reach, here it's called algae oil, yeah, we are reaching, if we compare the CO2 equivalent emission, we are reaching a lot less than from, like, if we would use fish oil or also plant-derived oil. Yeah, so it's a substantially less amount of CO2 equivalent emission. If we look to the costs, actually, we have in our process, then we can compete with the traditional fish meal supply of DHA, which is a good sign. Yeah, usually biotech processes are more expensive, but here we reach the same level, but we are much more sustainable. So it's a good sign. Let me shortly give an outlook what we will do further. So since we valorize now the, let's say, liquid phase of that dark fermentation, of this microbial hydrolysis process a lot, we still have to have a look what we do with the solid phase that is not degraded. So that's the lignin. And there we are currently working with the chemists, with the chemistry department at TU Berlin, to valorize also the lignin part of the straw by coupling it with chemo and electrocatalytic processes. So we are on that way. We are also currently working on other processes where we want to use and apply this dark fermentation effluent. So it can be even for biopharmaceutical production, recombinant protein production, but mostly also due to regulatory issues, we are concentrating on the commodities and biofuel production with yeasts. That is very interesting. Yeah, that's then just a final overview, and thank you to all the people that actually contributed to the data I showed you. That is primarily a work group still at TU Berlin, while I'm getting also bigger group here in Denmark. And yeah, also thanks to our external collaborators. This is actually how the fish DHA containing dried algae suspension looks for. We are using this in fish feed experiments up to a 9-ton scale. And I thank you for your attention and for the opportunity to present our research here. Thanks a lot.
Thank you, Stefan, for the next great presentation. Thank you. Maybe one question. Yeah, please.
If I may.
Yeah, please.
Hello, Stefan. Beautiful presentation, great job, and yeah, I'm a colleague of yours from biogas industry, and plug flow is very perspective technology, and no doubt that controlling it very, very interesting approach. My question is as such, do you see this technology go big? I mean, on scale?
Yes, so there are already plug flow digesters applied, and then it's a matter of what you want to produce in these plug flow reactors. So you can use the same size like the commercial size, usually it's several thousand cubic meters. You can use the same size and do exactly this. But I see the bigger potential for at least if I see the German market, the Swedish market, also the Danish market, I see the potential of what I presented you rather in having a separate unit, a plug flow reactor that is actually smaller than the big standalone plug flow reactors in front of the classical stir tank round full digesters. Because in such a dark fermentation process, you can have a better control and actually increase the degradation of this recalcitrant feedstock better than in a classical digester. So we are also working together with companies which actually build bioreactors and bioreactor plants. And also there are even more companies now thinking of combining the plug flow technology with the classical one, having the plug flow as a pre-digester, and then the size of the pre-digester is that has something to do with the residence times you would apply in both concepts. Then the plug flow reactor would be about 1/5 of the size, or let's say capacity, than the main round digester. So if the main round digester would be, for example, I don't know, 10,000 cubic meters in liquid volume scale, then the plug flow digester would be 2,000 cubic meters.
What do you think about, let's say, multi-stage digestion?
Yeah, exactly. That would be exactly the multi-stage digestion. Yes. Yeah. So you would have one stage. The first stage would be the hydrolytic acidogenic stage. And then you would have, in the second stage, you would have a dominant methanogenic stage, while you still have in the background some hydrolytic and acidogenic processes from the feedstock that was not completely degraded in the first stage.
Well, I think we have to exchange the contact information.
Yeah.
Thank
You're welcome.
I
You
will
can
tell
write me a short email. You see here my email address, then I will have yours as well.
Okay, guys, you will contact, you will discuss. Okay, thank you very much. Thank you, Stefan. And by the way, just Dmitro, I guess, will be our next reporter. Thank you very much, Stefan. We have, colleagues, we have a small change in our agenda, in our program. Our colleague from Austria will report at the end of today's second plenary session some issues. And now my pleasure to introduce our Ukrainian technological company. It's the name of the company, yeah, UTC, and Dmitro Krasutsky. Actually, we know you are here. Please, Dmitro.
Hello, everybody. Hello, dear colleagues. I am apologetic for the noise around me. I had the chance to participate in IFET exhibition in Munich, which is devoted to biogas technology. And I will share with you our practical experience in Ukraine, working with agricultural waste and waste of processing agricultural products. And if you can start my presentation, please. share the share it.
Yeah, I will help. Just a moment.
Mhm. Well, I would like to say a few words about our company, Ukrainian technological company or Ukrainian engineering company, is company with 28 years of experience doing the biological processes on industrial scale in Ukraine. Our company have two major partners that are presenting European technological school. This is Interis company from France and Adverio company from the Netherlands. We are using their licensed technology together with them and build biogas and bioethanol plants in Ukraine. Next slide, please. So as you can see, in 28 working years, we built 24 plants. We can start 30, and in general, about 180 projects implemented. Below you see our main partners in crime. Interis, Adverio, Pure, Pentair, likewise Halfmans. Most of these companies are let's say, large-scale industrial plant builders. And Pure is our biological partner from Netherlands who design unique biological processes. As a colleague who spoke before me. Next slide, please. Ukraine have tremendous potential as a grain producer, as agricultural, largest agricultural player in Europe. You can see how much grain we produce during the year. You can see how much sugar we produce during the year. And you can see how much vegetable and fruits we produce during the year. All that has a tremendous potential for deep processing technology. And as consequences of this deep processing, we will have waste of that processing that needs to be utilized. Considering the situation our country at in the moment and the problem with exports, that's approach took a massive character in our country. More and more companies want to process their grains and their agricultural products. Next slide, please. You see the potential growth from 100 million to 500 million to 1 billion just within one small century we all started. So the difference between waste disposal and recycling. Biological processes take something that cannot be used again. And it's not a plastic, it's not a glass, it's not a metal. So if it gonna decompose by itself, it will release all the methane and CO2 gases into the atmosphere, and we don't want that. So good waste management will bring your cost down 5 to 10%. This is percentage usually taken by heat and electricity consumption that can be produced from it. You will minimize your negative impact on the environment, and it will give you additional profit for sure. You will have access.
Вони, може, знають її.
You
Ну,
will have
знаєте,
access.
умовно, да?
Колега, мікрофон.
Олена. You will produce more energy and more electricity than you need. You can share it with in a grid in form of electricity or biomethane. Next slide, please. So about the profits and premiums you will get. If you use, let's say, grain waste, infected waste that was fungal infected, you will produce the bioethanol from the waste. So we will get advanced in certain percentage bioethanol. And that will give you or might give you the premium of around 200 euros to the stock price of bioethanol at the moment. It will double up your profit. Biomethane that produced from waste of bioethanol production. If you produce bioethanol from waste, you get double waste at the end that cannot be used for feed or food. And that will give you biomethane, which has a premium that is approximately double the price of natural gas at the TTF stock exchange. But the most profitable product you can produce from waste is bioenergy. Bioenergy is considered to be as a motor fuel, and the bioenergy was highest CI score. CI is carbon intensity. I mean, the highest in negative form. So as low as possible it should be, and produced on different biological waste will give you significant profit and almost 40% on top of price. Regular liquefied natural gas. So it makes sense to produce bioenergy only from waste that give negative carbon intensity score, which is all sorts of manure, municipal sludge, and food wastes. Next slide, please. If you look at Ukraine in the United States, you will see a mirror situation. Ukraine, unfortunately, exports 80% of agricultural crops they produce, and they process only 20%. USA is vice versa, exporting only 20% and use internally 80%. So our future to equalize our export and internal consumption, which would be a tremendous amount in the European Union. When we're going to be part of it, I'm sure we will be part of it. We'll have to think how to deal with that deficit of processed grains and all the products that come from them. Next slide, please. So, global perspective on organic waste and waste management. If 100 million bioethanol produced per year in the world, 50 million diesel and biogas, it will give the excess of it can be processed into SAF, so-called sustainable aviation fuel. Replacing gasoline by bioethanol already took place, and in average it's 7% in Europe, and hopefully it's already 10% in Ukraine. Some countries are using it up to 27%, like Brazil, and Brazil is planned to use 35% bioethanol in the gasoline mix, which is significantly will increase the world consumption of bioethanol. But at the moment, bioethanol market in the world is flat, so it reached some sort of level that cannot grow fast. To get to the goals of European rules and obligations they took, they're trying to replace the aviation fuel with sustainable form of it. That's where biomethane, hydrogen, bioethanol, and waste of oil, I mean oils from soya and other technical cultures comes in handy. Can we go further? Here I placed side by side two main technology for oil waste. I highlight oil waste, not good quality oils, is being processed as demo. This is HVO. It's a new approach that is replacing currently biodiesel approach by hydrogenation of oils with further hydrogenolysis, where we receive a long chain carbon carboxylic acids, long chains, not short chains, which will be decarboxylized after, and at the end of the process, we will get the linear molecules without double bonds, without oxygen, which was all hydrogenated by hydrogen, and a few byproducts, propane, short, which can be liquefied separately. When we look at the old technology, biodiesel, we're using triglycerides and with alkali catalyst, sodium hydroxide or potassium hydroxide, with methanol or ethanol possibly, we will get the mixture of esters. If you go to the next slide, you will see the difference that makes. Here is a comparison of quality indicator for mineral diesel, biodiesel, and renewable diesel. As you see, renewable diesel is complete analog of mineral diesel, have very similar properties, lower density a bit, and very low sulfur content. Calorific value is a little bit bigger and lower temperature of passing the filter. That means it can completely replace the mineral diesel because this is the same linear molecule. Biodiesel, on the other hand, has oxygen content of 11%, which is a little bit too much for diesel engines and can be used only up to 15 to 20% in the mix, when renewable diesel can be used as a complete substitution. So cetane, higher cetane number, lower emission, lower consumption, lower gelation point. That's an advantage. Disadvantage of this process that it is quite expensive technology because it's using hydrogen. So if you have excess of electricity, if you have cheap hydrogen, and you want to export it in the form of HVO, this is business for you. But you have to consider the scale to process it, because for such plant you need approximately 100,000 tons a year of oil waste. I highlight oil waste. Then your HVO will cost will have a high cost if you will produce it from sunflower oil, God forbid, or soya oil. The price of it will be lower. Next slide. Next slide. Please. So, bioethanol production. What is bioethanol? Bioethanol, it is absolutely waterless or absolutely dry ethanol. It is used as additive to gasoline. You see in which percentage, and it actually improves the efficiency of the engines. And in old days and now, but on smaller scale, from it we used to produce ethyl butyl esters. This technology is available only for, let's say, oil processing company who has isobutyl alcohol as a side product. We can use standard grain. We can use grain waste. As I said before, we can use infected grains. From good grains, we will produce not only bioethanol, we also will produce a feed for the animals. Cow, fish, pigs, you name it. If we produce if we can produce feed from our waste, we cannot use it in digestion because we receive biomethane with very high CI score, and nobody wants to buy it. This biomethane can be used only for your own needs to replace the natural gas or producing this for your needs. This if you will look in the cost structure of bioethanol, 75% of it is grain, 20 is energy, and 5 is chemicals and enzymes and all the rest. Next slide, please. So, world production, as we said before, of 128 million, 113 out of it is bioethanol. So technical purposes in food grade ethanol is used in very, very, very small portions. Mostly bioethanol produced as a fuel additive. Brazil is a leader, 27%, and they started to add it even into diesel. A very small amount, but it's working. Argentina, 12, Europe, 10, but in average it's 7 at the moment. And we plan on doing it in Ukraine. Start adding bioethanol in Ukraine is very important because it's completely binded to the quota we have to export bioethanol in Europe. At the moment, the market of Ukraine is around 200,000 tons of bioethanol, and we have 100,000 ton quota for export. Last year, we used this quota for 70,000 tons. But with the rate of growth of bioethanol plants in Ukraine, we will get this quota out very fast. I think this year or next year, it will be to extend our quota, like Pakistan, for example, extended from 100,000 to 500,000 tons per year. We need to increase local consumption of bioethanol in Ukraine. So the law that will obligate our gasoline producers and gasoline traders to sell bioethanol in our gasoline will increase the inner market, local market for 100,000 tons. Next slide. This is if we look in the left low corner, you will see the biggest countries that is selling ethanol. So it's US, Brazil, UK, Pakistan. For Pakistan, it's a little bit old figure. Now Pakistan taking the first place. And the reason for that they produce bioethanol from cane molasses. Cane molasses, sugar molasses, or soy molasses are suitable for bioethanol production. And this market is about 13 to 15% of global market of bioethanol. Most of that molasses considered to be waste. Not by all countries, but there's always a buyer. And this sorts of bioethanol is being bought first because it brings the highest GHG with it. So it's kind of like you buying CO2 in form of VAT. You bought it with your ethanol, you added for gasoline, you have to pay for it every single year. This is what. And we see Ukraine finally took place with the 30,000 tons, which is already bigger and will grow. And I think we will replace Guatemala and definitely will replace Russia. Next slide, please. Next slide, please. Okay. What we can do? Well, we collect Ukraine collected before the wartime 36 million tons of grains. If we have 1% of grain waste, 2% including mycotoxin infected waste, that is tremendous amount of corn to be processed inside of Ukraine. Besides the corn, on the field, we grow corn leftovers that is left in the field after corn collected, and that needs some attention to be decomposed in the field. Decomposing in the field takes out of the ground certain NPK levels, and if we take 70% out of the field and digest it, we're not going to influence NPK balance in the field, because we will return that NPK back in forms digested. But if we burn corn leftovers, then we will not replace it. We only will bring back ash, the absolute mineral content without organic part of it. So yes, as I said before, 80 to 20 has to be changed to 50 to 50 at least. Next slide, please. Here is a few simple approaches that usually take place in the world, and it's these approaches changes. Changes with some time. Corn can be processed into bioethanol, DDGS as a feed, and liquefied CO2. Unfortunately, market of CO2, liquefied CO2 is not big enough to consume all the CO2 is produced in the bioethanol industry. Feed plus energy. You process corn to bioethanol, you can get concentrated CO and high protein feeds. And part of your stillage that is not interesting as a feed can go into biogas for all needs, as I said before. Surplus goes for sale in different form, and biofertilizers returns to the field to keep balanced NPK. Energy production can be done from biogas, and biogas can be converted to biomethane. Biomethane in gas form can be grid, or in liquid form can be exported as an interfuel. Again, biofertilizers stays in the grid. So these approaches, all these approaches already done in Ukraine. So we built ones that is producing DDGS in more simple form in DDG, and as solubles goes to the digestion, and we're building liquefaction of CO2 into the people, and we are using biogas for biogas production with stillage in Yosef Nikolaevka and for production of liquefied biomethane. So these technologies are kind of new for Ukraine, not for the world, but they are approaching. Next slide, please. A few forms of converting raw materials to biogas. Shown as a simple plant, as Stefan was saying before. First, good preparation, a little bit of hydrolysis, then highly reactive industrial scale, and post-digestion. 3-step minimum, which isn't. You can produce electricity, and heat, you can produce a steam, or you can go to biomethane approach. To local grid, to transporting grid, to motor fuel, or to compressed, which is quite available. CNG stations in Ukraine. And by the way, yesterday, President of Ukraine signed release for biomethane export. So I think this will start the new, let's say, economic income of currency in Ukraine. So this was very visible. Next slide, please. What is potential? So the main topic of my presentation, the potential. We have up to 300 million tons of waste generated per year. Can you imagine this amount, this volume? This is unbelievable. We can produce 15 billion cubic meters of biomethane, according to UTC estimation, which is quite close to estimation of European Biogas Association. 15 billion cubic meters. The whole Europe trying to reach 30. And we can supply 15. So Ukraine will be a significant player. It's not going to happen tomorrow. It's going to happen over, let's say, 15, 20 years. But still, this is tremendous. Income in euro payments in the European. Next slide, please. I did not expect you to read it all. You can read it later. But these are the main wastes that are available in Ukraine. Mostly it's food production industry, the waste of food production industry, the agricultural wastes of the municipal sludge wastes. You will go through it and see that they have huge potential. Next slide. Okay, raw material that fit resolution red 3 very well and can produce, let's say, expensive biogas and expensive biomethane out of it. Stefan can see lots of dry materials that are screaming for plug flow reactor. And most of them gives a very good premium. So in previous table, you can find the amount of this material available. But as for now, I can say that corn leftovers and husks, as well as straw manure, is going to be the main game changer in the biogas industry. So we have to learn how to convert it well with high conversion ratio and with high biogas yield in a short period of time. Next slide. Sorry for the noise. It's impossible to hide here. Next slide. Not all materials gives expensive biomethane. Some materials that can be used as a some materials that can be used as a feed for the animals. Can we go back? Can we go? Oh, thank you. So you see corn silage, which is energy crop, and our company is not using corn silage as in installations we built. We widely use beet pulp, which is by classification in Ukraine is a waste, but not a waste if you will ask our European colleagues. It can be dried and converted to animal feed, despite the fact that we have too much of it, not enough cows, and there are some legal things that needs to be resolved. Grain stillage, a perfect raw material for biogas, but only makes profit if it's infected or done from grain wastes. Beet tops is a waste. A fruit pulp is a waste, vegetable waste, and beet tails and some leaves is a good waste to be used for biogas production. Good source of carbon, same as straw which complements well all the manures that needs to be converted as well. Next slide, please.
Dmitry, I'm sorry, would you finalize a little bit?
Yes, I will finalize.
Okay.
So let's go quickly. Short scheme for sustainable aviation fuel. Unfortunately, very expensive technology for Ukraine at the moment. It's billions of euros and available only for European oil companies, but we can supply ethanol to them. Next slide. This is another technology that gives the possibility to transform biomethane by catalytic process, high pressure, high temperature to renewable chemicals that can start the chain of chemical production. Next slide. The digestate cannot be overestimated. It's a great source of available for plants NPK in good forms that can be immediately available for the plants, much better than regular manure because it's already mineralized and brought from organic form to mineral form. Next slide. Our installation that partially belonged to UTC is the Joseph Nikolaev installation that mostly consuming 70% of chicken manure and 30% of other carbon containing. Currently, we're doing 5 megawatt to the grid, and starting this year, we will be additionally we will produce 20 tons of liquefied biomethane a day. For my colleague, I want to say that this station is working at 11 kilogram organic load. 11 kilogram per cubic meters per day. Yeah. Next slide, please. Not 3.5, not 11. That's how it looks at the moment. It's we can bring it from 5 megawatt to 10 megawatt in 2 weeks time when the sugar plant next to it working. We using surplus of biogas to replace natural gas. Later this year, it will be converted to liquefied bioethanol. Stefan, on the left side, this is 2,500 cubes hydrolyzer, the first hydrolyzer in such scale that is working. So we need to talk about your monitoring, because now we only monitor redox pH and some other parameters. Next slide, please. Examples of bioethanol plants that our company took participation in. Gniedava completely built plant. Teofipol, we finished this year second stage. Now it's producing 24,000 decaliters or 240 cubes a day. We took participation in Pannonia, the largest bioethanol producer in Hungary and in Europe, and Lillebonne bioethanol plant in France, very significant example together with Interis company. Next slide. Next. Okay, biogas plants. If we can go back. So we built mostly big bioethanol plants. Like in the starter, we built 18 megawatt plant. In Josepha Nikolaevska, we did 10 megawatt plant. Little plant in Kozhenka, 1.5 megawatt. Teofipol, 4 megawatt, and even in Bobruisk in old days, we did utilization of stillage together with Adverio company, of course. Next slide. We are done. So the conclusions. We can solve the problem of excess of feed materials. Bioethanol is controlling the excess to keep the prices even. If we have shortage of food materials, we stop producing bioethanol. It's simple. And if we have too much, we produce bioethanol. So food security will not be effective. Energy security, export to keep hryvnia stable, improve the environmental conditions, and restoring the soil fertility. For example, using digestate for 3 years will improve humus content at 0.5%. This is a big step. And we can boost our industry. We can boost our jobs. We can build good production sites that gives the good salary and attracts our people back from Europe. So it's all connected. We have to do it. We have to do it right. So that's it. Thank you. Sorry for taking it so long.
Thank you, Dmytro. You see how serious, how cool is Ukrainian biotechnological business, yeah, and UTC, yeah, a little bit problem with time management, but it's okay, it's okay. Yeah, Stefan, please.
Yeah, yeah, but we do have experience. We would love to share it. And
yeah, it's okay. Yeah, thank you. Stefan, please.
Yeah, thank you for this very interesting talk. I would have one question, probably I didn't get it. I think it was on slide 7. You showed additional numbers in green for the biogas and bio-LNG. And that was not the market value, or what was it? Can you explain a little bit more about these values?
I showed 700 euros per cubic meters of bioethanol, which is quite close now, 683 this morning I checked. And if you produce it from waste with GG level over 85, in countries like Switzerland or in countries like Great Britain, you can get, it's not guaranteed, additional premium of 160, 190, 200 euros plus.
Yeah, okay. Yeah, okay.
I only share the figures of our clients and from the last of the 100.
And probably a very short last question. What is like in countries like Ukraine, is the tendency going to rather to biogas or to upgrading it to biomethane? Because you also showed the washers for upgrading biomethane. So are these rather small size plants? Because then this technology is is a bit critical due to the revenues, or are you rather talking about big units, centralized units, where then an upgrade from biogas to biomethane is made? What is the tendency? What is the trend?
The trend is following. Starting last year, we cannot get the entire anymore. So you either produce electricity for your own needs, then you slowly pay back. You can
Sorry, I guess we have some problem with connections. Dmytro? No. Okay. I think we may contact with Dmytro later. Hopefully, yeah. Hopefully. Thank you. And
I'm sorry. May I ask then, if not Dmytro, then Stefan, because they
no, Ola, wait. We are out of time. Sorry. We will have a discussion session. Yeah, we will have a discussion session.
But
yeah.
maybe I just ask them, they should not answer. Maybe
Ola, wait a little bit. Ola, wait a little bit. No.
Okay.
Sorry, Stefan.
You can also write it in the chat. Write your question in the chat.
You might communicate in chat or just.
It might be very important questions in context of safety of contamination.
Sorry.
And diseases.
Guys, sorry, Ola. I see Paula. Are you with us? Yeah, correct.
Yes, I am here.
Yeah, but so my very important question: do you have your presentation with you? Because I didn't get it on my device.
Let me see if I can
Okay.
make it available. Just a
So,
second.
guys, I am sorry to interrupt in Ola and Stefan. Yeah. So please, yeah, really, we are close to our finish of our section and to our lunch. That is why I am worried. Our next presentation. My pleasure to introduce Dr. Paola Canelas de Castro, our reliable partner from the University of Macau and the University from Portugal. So, Paula, please, the floor is yours.
Thank you very much. I was just trying to see if I can launch my presentation, which strangely I seem to be having difficulty doing. I don't really, if you can just bear with me for 1 minute, please.
Okay.
Let me try to see if I can solve this. Okay.
Yes.
I think you should have it now.
Yeah. Yes.
Okay. 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 First of all, of course, let me say that I'm very honored for being here in your reflection in Ukraine on the European dimensions of sustainable development, and doing so with my dear friend Igor Yakimenko. I've been very, very privileged, as maybe a few of you know, for coming to Ukraine after the Maidan events on a number of times. And of course, ever since I've been, I'd say, very emotionally engaged, I can say, with your country's pathway. For that as well, when Igor challenged me to again return to you via Zoom, I could not but say yes, irrespective of the fact that this falls in between 2 different conferences in 3 different continents. Anyway, with much pleasure, I also picked up the topic that Igor kindly assigned to me, which has to do with a momentous issue in many European member states, certainly in mine of nationality, Portugal, although, as you may know, I'm working now in China. I am a professor from the University of Macau, as well as a professor from the University of Coimbra in Portugal, and the leader of the Institute of European Studies in Macau, which is China. It's a special jurisdiction in China. The question which I'd like to reflect on has to do with how much European Union water law and policy meets the challenges of today, which derive from obvious climate change. More and more extreme events are happening, are impacting, well, the very first media water, and how much water can be used, and its law can be used to moderate these impacts, to respond to these impacts, to adapt to these momentous impacts. I think this is a tremendous challenge, which stays there very high in the agenda of, let's say, sustainable development in many parts of Europe. Certainly in a country like mine, where, to give you just an example, we have seen the average of flows, and these, of course, are flows shared with Spain, usually the upstream country, flows in rivers sometimes decrease by as much as 70, 80, 90%. Which is really a dramatic situation, as you may understand. Now, I don't have to tell you, of course, that climate changes on Europe are becoming very visible, that this translates, of course, in warming up. We are already probably over the limits that the Paris Agreement set to us, and we are witnessing more and more dire situations coming with that. Summer heat waves, heavy precipitation in some places, in some other ones like Southern Europe, Portugal, for instance, very severe droughts, not occasional ones, but ones which range for years and years, and also high rising sea levels. For instance, just to give you an example, this is very visible in any graph, and also in terms of, let's say, the health implications, the human implications that this is already bearing for many parts of Europe. I don't have to tell you either that these last years we have average temperatures never seen before, particularly in summertime, but also outside of summertime, and that Europe in particular is suffering more from that than other parts of the world, although this is a phenomenon which can also be very palpably experimented, for instance, in the area of the world where I'm now working more regularly, China. Now, these environmental impacts translate, as I said already, in the frequency of extreme sea levels and coastal floats. We all sense that the adaptation to these climate changes is inextricably linked to water management. It's in water that some of these impacts are felt more directly. It's also water which may be providing the key for dealing with these impacts, and in particular, adapting to them. This touches, of course, how we try to govern, let's say, our issues, our social issues. And we know that for that we are equipped traditionally in regard to water with a set of legislation that is epitomized by the EU Water Framework Directive. It's nothing new in European Union environmental law that governance is regulated in law. I mean, Europe is a union of law, not a state of law, but a union of law. Law governs the attitudes of the different players, decision makers, authorities, the citizens. And we have come, I would say, a long way from the humble beginnings of the European Union water legislation, which, by the way, was one of the forerunners of the European Union momentous environmental legislation that we have accumulated from the 70s onwards. You know for sure that at the beginning, this water legislation was very piecemeal and responsive to some specific problems. It evolved from setting some standards for specific water bodies used as drinking water sources, and then over different decades enlarged to cover more issues, include binding quality standards for the protection of drinking water for sure, but also for fisheries, shellfish beds, bathing waters, and groundwater. And in addition, at a later stage, the second wave, if you want, of European Union water legislation, there was an attempt at dealing in a more comprehensive and harmonious way, integrated way, with different strategies of prevention and control of pollution. The IPPC directive being, let's say, one good example of this. All this then was matured at the change of the centuries and the millennia, really, with the production of the European Union Water Framework Directive. Some of you may know that I've been very much involved in that. It was under the Portuguese presidency that this piece of legislation was adopted. And I'm sure you also know the features of this legislation, which abandons, in a certain sense, a sector-specific approach, which tries to have a very holistic approach towards the management of the different water issues integrated with some key cardinal choices, like, for instance, basing itself on a river basin approach for assessing this integrated management. This is really a new beginning, if you want, in the history of European Union water law and policy by prescribing this river basin management approach and expanding the scope of water protection together with the water utilization to all water bodies for promoting the sustainable use thereof, and certainly trying to link water management with other policies at different multi-level decision-making, and with the participation of the public, a very large public participation, a way of disseminating, let's say, this more ambitious narrative in regard to the reality of water bodies. And these governed by defining certain goals. And as you know, Article 4 of the Water Framework Directive, which sets the environmental objectives, is an important building block of that. This is the substantive choice to render waters of good quality, let's say it, of course, according to different parameters. This has implications for the ecological reality, for the chemical reality, for the quantity reality, for different types of bodies, and doing this over a timeline in a very, if you want, concrete way. These goals have to be attained, on the second round, to which we are coming close in 2027, ideally in 2015, 2027 being the default time. The directive is characterized by its appeal to planning at the basis of that or a scale which is the basin, a planning which is cyclical, based on programs of measures which translate, let's say, the different ambitions to different palpable actions in order indeed to deal with the different impacts of human activities on the water system and to review that cyclically, which is one of the innovations of this directive, which is very important for our issue because, as you know, in face of this momentous climate change, one of the first problem is precisely how to adapt, how to bring in new solutions to problems as they are detected. And this, let's say, sense of time, which did not used to exist in previous directives. And really, the Water Framework Directive is at the forefront of a trend which is now seeping into other areas of legislation across the environmental arena, but also other ones, is a very important tool. We know that this program of measures is based on a combined approach for encompassing precisely not only emission limits regarding point and diffuse sources, but also quality standards, and trying really to address different kinds of activities from the industrial sector, also to the agricultural one, and considering even the, let's say, economic and social dimensions of this. One feature of this attention to reality, because, let's say, this ecological sensitive message, in a certain sense, also takes into consideration the sensitivity to society, is that this is supposed to be done with very close, very engaged public participation in the whole process, the public may participate at large in making plans, in adopting measures, in contributing thereto, and also because there is the realization, which was much discussed where one was preparing this draft, that knowledge is sometimes very democratically placed, in the sense that sometimes the knowledge of a local fisherman can be as good as any bureaucrat in the capital, if not better, for indeed making a plan, making a program of measures which is really workable, which is effective, and which has impacts and may change the situation for the best. For that, of course, information is a key departing point. It has to be very openly and readily and transparently made available as a condition for participation. And then also access to courts. The idea, access to justice, is another building block of this system. You know that this was more normatively integrated in the Aarhus Convention, but that is translated also in the European Union legislation, in particular this piece of legislation, the Water Framework Directive that we are talking of. Access to justice, permitting precisely that not only the Commission, which is really a gatekeeper of the system as in view of its competencies, in view of its rights, is accompanied by the individuals who may bring cases to the court, as long as they demonstrate some kind of direct interest. Again, if you want a democratization, not only at the level of designing, let's say, the policy, but also making sure that it comes true, that there are safeguards, that there are measures to bring in new information, if you want, in view of reality, particularly where it does not match the expectations. Now, for that as well, the whole construction foresees and establishes a monitoring system and the capacity of the system to bring in, to factor in information as it comes about. Again, this is something that, particularly for lawyers, was at the beginning quite strange to have this notion from the beginning and building it into the very legal provisions that law is not a black print letter. Law is all that comes in different steps by bringing in information of different kind to the system, and that this law evolves and is redone in a certain sense as monitoring detects, well, situations which have to be taken into consideration and brings in new ideas and new solutions for them. On that, as I have said, the Commission has a particularly important role. It has been indeed exerting its competencies. It has been carrying out its competencies, denouncing different situations, discussing with states, member states, the ways to ameliorate. And there is indeed a lot to be done still to ameliorate. Precisely the first reports, I'm just mentioning in this slide first one, but other ones at different levels of planning have not basically fundamentally changed the picture, which I tried to sum up there, demonstrates that irrespective of the ambition, the situation still demonstrates to be very distant from there. The quality of the water bodies, the number of water bodies which have attained good status at large is far from acceptable. And the more we are bringing in knowledge, for instance, on climate change, and have to also factor in other actions, like, for instance, building barriers, etc., the more it is difficult to find the right trade-offs for meeting the goal of good water status if it persists to be the one as it is. So the big question becomes then precisely, to what extent does this European Union water legislation and policy contribute towards the resilience in adaptation to climate change, which we are also setting as a goal in the European Union. We know that the principle of resilience, which is a concept which comes from ecology, as you know, has not really been brought in as such or defined in European Union treaties or even in secondary European Union legislation. There are now a few policy strategy papers which are going more carefully into that. But we know also that there are different definitions of resilience. But at large, the idea is that one has to build capacity, to invest on capacity to absorb the disruptions deriving from different sources, and in particular, the climate one, and respond thereto gradually over time. And we also know more and more that water plays a role in that. Adaptive water management is crucial for fighting climate change and for precisely building that resilience that the European Union strategies are calling for and responding to the anxieties and demands of the citizens. After all, the European Union is for, by the citizens. Adaptation being defined as anticipating the adverse effects of climate change and taking appropriate action to prevent or minimize the damages it may cause. Now, this is not only a wishful thinking, but really a must. The European Union has been construing the legal basis, particularly looking at articles, some key provisions of the treaties as mandates for acting in this area and as obligations for the states also to proactively act, to seek to contribute to the protection of human health and the prudent and rational use of natural resources on a more comprehensive way. Again, the principles which guide the different actors are not very different from the principles that we know in European Union environmental law at large, with an emphasis on prevention and also precaution, but also the idea of participation of the public. It is very important because these affects the livelihoods of people, that people are empowered also for designing and also contributing and also acting in view of the results of these policies. What are some of the building blocks of these policies of adaptation? Certainly the idea that the rules which, let's say, orient us in the governance of these matters are to be flexible and adaptive themselves, which for lawyers in particular, and I'm a lawyer, is a big challenge to see, let's say, legal documents not as the last word, but really as a reference point which has to be regularly checked upon and revigorated. For that, another building block is the openness and public participation and access to information. The coordination and integration across sectors and levels of governance to ameliorate these cooperation ventures between the different levels of governance, and having a constant administrative attitude of monitoring and evaluating, assessing, and then trying to adjust in face of reality. Substantively, by promoting nature-based solutions and ecosystem-based adaptation. This is the approach of the EU on an emerging principle of resilience, which has been taken up, if you want, in a recent paper, the European Union White Paper on Adapting to Climate Change, which puts a lot of emphasis on this dynamic acting with a certain number of pillars which sustain this whole strategy. The idea of knowledge. It is necessary to build knowledge to always harness information, bring in and factoring it in decision making, integrating adaptation into key policy areas. These different policies cannot be let's say, unilaterally pursued. The water policy has to have some integration with the one on climate, the one on energy for sure, and the agricultural policy, to name just a few. Also employing a combination of policy instruments. It's not only, let's say, the command and control attitude, more and more, precisely because there are people involved, because there are enterprises involved, that they are sometimes decisive for certain areas of these policies. It is necessary also for bringing in market-based instruments and translating these key laws into guidelines which bridge the gap to different implementers, if you want, of these policies. And then to be very aware of an international dimension of these tasks, of these endeavors, and promoting the coordination and international coordination of these efforts. The white paper can stand as really a framework to reduce the European Union vulnerability to the impacts of climate change, and water plays a decisive role in there. One idea which has a particular, let's say, one of the implications of this approach for lawyers is that we have to contribute towards striking an appropriate and sometimes very innovative balance between legal certainty and adaptation and dynamics. The old ways we used to capture change or allow for change, like force majeure or change circumstances, is not anymore the way, because this is too rigid. This can only intervene in very extreme situations for having the very legal system adapt. And also permitting access to courts, because people at this diffuse level are actually some of the best, I would say, watchdogs of this policy turning true. I would like just to recall that this is an effort where we are not alone, that there are, let's say, similar, let's call it strategies being adopted at the international level, the European Union standing as one of the promoters of this, and that the European Union has also recently matured these thoughts into the policy paper, the European Union Adaptation Strategy, adopted in 2021, which in many ways calls for more proactive, let's say, involvement, engagement, in particular for ensuring that by 2050, as you know, we have decarbonized and become also more resilient in view of that. The strategy has 4 principal objectives: to make adaptation smarter, swifter, more systemic, and to set up international action on adaptation to climate change. Smarter means that, precisely as also mentioned, to build on more and more information, data, risk assessment. There are some new plans which are necessary in view of trying to harness this information. For instance, faster adaptation means that there is a focusing on developing and rolling out adaptation solutions to help reduce climate-related risk, increase climate protection, and safeguard the availability of fresh water. This is the challenge, for instance, in Portugal, in Spain. We cannot draw scenarios on the basis of, let's say, 2 long periods, 100 periods, by assuming that if changes, if there is a variation, it shall be of twofold for more or for less of the average. We are faced with situations where the factors augment immensely, and there is variations in time also very, very important. We are not anymore at, as one author said, analogic times where we can opt for analogous solutions. On the contrary, we live in another world, for sure, also in regard to water. Systemic adaptation, well, this has to translate at all levels of governance with certain substantive guidelines, like the constant attention to the processes of nature, to ecological processes in particular. And then to do it also at the international level, because scale matters. Scale is the key. Finally, just to recall that we have another piece of legislation, very important, which was adopted also in 2021, the European Union Climate Law, which lends a little bit more of coherence to this endeavor, and which calls very interestingly, which more systematically brings in these ideas, but which calls very interestingly to the importance of, indeed, participation of citizens, the empowerment of citizens, their capacity to come and have their voice heard, as it is so important, and which explains, for instance, the rising European Union climate litigation, but also which calls the attention, for instance, for an area where in water we have been less cautious, which was, for instance, how much this translates into designing the legal tools at the level of the actual water consumers, if you want, who have water rights, who have permits to abstract waters, etc., in also a more dynamic way. Because these are actions which are to be taken by the member states, which are to be taken or, let's say, implemented or monitored or enforced by the European Commission, by European bodies, but which affect also the rights of individuals, of enterprises, who may have to have their licenses reviewed very quickly in face of different circumstances. And how can we still do so in respecting certain key ideas which are structural in the European Union, like rule of law, like a certain level of certainty in this growing uncertainty. Final remarks. Well, current water law should reinforce the substantive and procedural flexibility of its provisions, their adaptability in order to facilitate adaptation. The idea of procedures is very important. The European Union law, as the Water Framework Directive, already has a lot on that, but we have to refine the procedures precisely, for instance, on how we revise or not water abstraction rights, on how we set new limits in regard to quality of water bodies, and how this impacts the owner of title, for instance. We must reinforce the effort at monitoring long-term changes, but also short-term hydrological changes. Then we have to put a lot of emphasis on how these different, I would say, planning, managerial, and legal tools are or not adapted to new circumstances, and not only those of a historical hydrological balance. And then the last point, which I have already insisted on, we have to think more and more on how to make sure that at the level where things really act in the field, if you want, how we can make innovative solutions for ensuring the review of licenses and water use rights that accommodate new hydrological circumstances without denying them, because the idea is not to deny them, but this calls for new thinking for sure, and certainly also on the part of lawyers whom I represent here. Thank you very much for your attention. This is my, let's say, overview of the problem. I'm, of course, open for any discussion.
Thank you, Paula, for deep insight into the European Union policies. It's very interesting for us. So, colleagues, maybe two questions, and we are done in first part of our plenary session. Paula, if I may, I am always interested about balance between the EU and the national EU member states, legislation and actually practical policy. For example, for your experience, how often they have these court cases, some issues, or it's more just I don't know, some negotiations?
I think that there are barriers to access to courts. Okay, the European Court of Justice in particular has been very clear on the idea that the judiciary system cannot be flooded by giving permission to everybody to bring in any case on a more, as they usually say, theoretical sense. Okay, there has to be, they always ask for a direct interest, that people in a certain sense may claim to have some kind of interest deriving from, for instance, harm which was caused to a certain individual. This was still a key issue in the recent cases that you may have heard of, which came up to the European Court of Human Rights on climate litigation. It's on climate that things are being tested more clearly. But we have witnessed also recently an effort, both on the part of European Court of Justice, say the specific courts within the European Union system, and on the part of the European Court of Human Rights, which is more wide encompassing and in which Ukraine is also an equal member to any European Union member state in that sense, more receptivity, more the perception that these problems are becoming much more acute, and this should translate into, I would say, facilitating further the access of people to courts. Still on the basis of some interest, but the way you interpret this direct interest as, let's say, the gateway to actually bringing in a court to the case, a case to the court, is interpreted more largely. You have seen, for instance, as you know, young people, also from Portugal, claiming that some states were not doing enough in fighting climate, and that this was of interest to them because they said, well, we shall be the generation who are going to suffer more from the inaction of the states. Well, in that, the court dismissed the case. But for instance, when certain ladies referred to the fact that the temperatures rising and affecting their health, well, they did bring, the court did listen to their case, and we shall see measures being taken out of that. So we are at the times where the system is being tested. And if I can, I do not have a crystal ball, of course, and I'm not tempted for doing this kind of guessing games, but I would say that we shall be witnessing in the coming times more and more a reflection also on the part of courts towards rendering this right of access to court much more operational, and more people bringing in cases, which may put more and more pressure on states in particular for, well, carrying out what they pledged in these different legal acts at European Union level, at international level, etc.
Okay, thank you. My question actually was the court cases, for example, the EU authorities against national authorities, something like that.
This is happening, as you know, and the European authorities have been, the Commission has been exerting a lot of pressure on member states, particularly precisely on the water domain. And there are huge fines which are attached. Well, Portugal is one of the victims. It was the country which was the leader in passing the European Union Water Framework Directive, and now it sees that some of its rules are used by the European Commission against Portugal in infringement cases, for instance, for late submission of plans, incomplete submission of programs of measures, etc., and these with fines attached. The countries feel the pinch, they feel the pain, so to say, for not, if you want, implementing perfectly the regime which all of them obey to, are supposed to obey to.
Okay, I got it. Okay. So thank you, Paula. Thank you a lot to being with us, for your ideas, for your experience. Dear colleagues, we are done for our first part of our today activities. And thanks a lot all of our speakers and all of you. I am sorry that we had some time issues. We actually have now lunchtime till 2 p.m. according to Kyiv time. Again, I am especially thankful for people with different time zone, like Paula. I am sorry, Paula. And now again, I will leave Zoom open. So please, we will return to our meeting, to our second part of plenary session at let's say 40 minutes. Yeah, Dr. Anatoly Kirich will be our next moderator, and just now you may have a free discussion in Zoom if you want to, I don't know, save a couple of minutes for your lunch. It's okay too, but it's up to you. It's up to you. Okay, guys. So yeah, thank you, Paula. Thank you.
I say bye. Thank you very much.
Thank
all the
you
best
very much.
to all of
We are
you.
meeting all
Ukraine at
together
large,
in 40
please.
minutes. Okay. Thank you. Thank you.